Hello, good morning. Welcome back to the third and last day of the 26th SINSM. Um, Mathematics and Computer Science track A pre-calculus and basic calculus with sub-theme Strengthening Senior High School and Tertiary Mathematics Instruction 2.0. And before we proceed with our program, I will take this opportunity to greet all mothers out there. Let us all celebrate the act of motherhood. To be a mother to someone, care for or protect like a mother. Happy Mother's Day to all super moms in the world. Happy Mother's Day to everyone caring and protecting a child like their own. Okay, before I introduce our lecturer for today, let me remind our attendees to please turn off their microphone and webcam during the lecture. The Q&A will take place at the end of the lecture. You may put your questions in the Zoom chat box or YouTube live chat. At the end of the lecture, the link for the evaluation form will be posted. Certificates will be awarded to attendees who attended at least 75% of all lectures in this workshop. In the next few hours, we will hear from a person born and raised in La Union. She had her bachelor's and master's degree in mathematics at the University of the Philippines, Baguio. Currently, she is a mathematics instructor in UP Baguio. She attended both local and international workshops, trainings, and conferences in mathematics, mathematical biology, and computer science. Besides mathematics, she likes to travel, watch K-dramas, and listen to K-music. Without further ado, please welcome Miss April Pajimola.
Hello, good morning. Can you hear me?
Yes, ma'am.
So I will just share my screen. Ayan. So thank you, Jayan, for that introduction. And again, thank you rin po sa mga umattend today sa last day ng ating training, which is the 26th Summer Institute in the Natural Sciences and Mathematics. So thank you po sa lahat ng umattend and Happy Mother's Day din po sa lahat po ng mothers out there. So yun po. So today, wait lang. Hello? Nakita na ba pala yung screen ko? Sorry.
Yes, ma'am.
Yeah, thank you. So today, I will be talking about the derivatives, or the title of my talk is on the K-12 Basic Calculus course, which is on derivatives. So yung pag-uusapan natin ngayon is some concepts, applications, and yes, tungkol sa derivatives. So yan. So, before tayo mag-start sa mismong lecture, so gusto ko lang munang magpasagot sana ng survey. So, ito pala yung outline ng magiging talk ko, no? And first, for the motivation, then define natin itong derivative gamit yung tangent line or slope of the tangent line, then some differentiability and differentiation rules, the higher order derivatives and the chain rule, implicit differentiation, and some applications in related rates. Ayan. And tulad nga ng sabi ko kanina before tayo mag-start, so pwedeng pakisagutan muna itong survey. Ito yung link niya. Ayun. So, post ko lang sa chat box yung mismong link. Ayan. So, pakitry lang po munang sagutan niyang survey. Share ko lang yung results. I need permission. Wait lang po. Ayun. Sorry, hindi pala napalitan yung permission. Okay na po ba? Ayan. So, maghintay lang muna tayo ng mga 2 minutes para makita yung result. Ano pa rin yung permission? Ayan. So, na-edit ko na po siya, no? So, habang hinihintay yung result, may isa pa po akong tanong. Kung naisip niyo po yung salitang or kung narinig niyo po yung salitang derivative, ano po yung first na ang pumapasok po sa isipan natin? So yun, paki-drop na rin lang po sa chat box habang hinihintay po natin yung result doon sa survey. Ayan. So I think okay na po ito, no? So yung tanong kasi dito is, which component of calculus do you enjoy studying and or teaching the most? And yung options is limits or are limits, derivatives, antiderivatives, trying to actually figure out what this mean, and complaining. So yung nananalo is itong derivatives. Ayan. Which is yung topic natin this morning. So balik lang po ako sa aking slide. Actually, yun po ay based dito sa meme na nakita ko online, no? Pero yung nanalo kasi dito is complaining. So baka itong survey na to is ginawa pala to nung baka mga students natin. Ayan. So okay naman po yung result, no? Derivatives po yung karamihan po nung na-enjoy yung component ng calculus. Ayan. Ano po pala yung nakikita niyong screen po ngayon? And balik tayo doon sa question kanina na when you hear the word derivative, so ano po yung unang pumapasok sa isipan natin? Ayan. So merong mga sumagot sa chat box ng slope, rate of change, slope of a line, slope of the tangent line, rate of change changes. Yan. So thank you po ulit sa mga sumagot. So actually ito nga po yung mga main or kung dinedefine kasi natin yung derivative, yung main na ginagamit natin is yung slope of the tangent line. Ayan. So thank you po ulit sa mga sumagot ng survey and dun din po sa mga nag-drop po ng sagot sa chat box. So proceed na tayo sa or mag-start na tayo sa lecture for today. Ayan. So nakita po ba ulit yung screen ko which is yung slides? Ayan po. So for the motivation, so alam kasi natin na or one of the most important themes in calculus is the study of motion. So kapag kunyari meron tayong moving object, yung laging tinatanong sa atin or kung given parati sa atin yung position and yung velocity ng object, yung laging tanong sa atin is what is the relationship of the velocity and the position? And in particular, we consider this maglev or magnetic levitation train, which is moving along a straight elevated monorail track. Ayan siya. And to consider or to describe the motion of this maglev, we can think of this track as the coordinate line. So in particular, kung alam natin yung position nitong maglev na to at all time t, paano natin kaya hanapin yung velocity at any time t? So to answer this, we use the concept of differentiation or the process of finding the derivative. So kung given tayo dito ng position s, then mahanap natin dito yung velocity which is si v. Ayun. And to define a derivative, yung laging or to formally define a derivative, we use the concept of the slope of a tangent line or the so-called tangent line problem. So paano ba natin mare-relate itong derivative sa rate of change and sa slope of a tangent line? Ayan. So usually kasi pag sa senior high, yung introduction dito is laging dinedefine na agad si derivative. Ayan. Or dinedefine yung slope of a tangent line, then sinasabi na ito na agad yung derivative. So, yung goal natin today is paano natin maire-relate tong tatlong ito. So, start tayo kay slope of a tangent line. Ayan. So, recall muna natin na si tangent line kasi at a point in a circle is defined as the line intersecting the circle at exactly at that point. However, yung tanong, our concern is, how do we define a tangent line on a general curve? Ayan. So, makita natin dito sa curve na to na hindi tangent line itong line na to since tinouch niya or krinos niya yung curve natin in at least 2 points. Ayan. So, to answer this, we consider this curve, y equals f of x. Then, we also consider 2 points P and Q along the curve y. Ayan. Si P yung coordinates niya is si x naught f of x naught and si Q is yung coordinates niya is si x f of x. So, dito, given tayo ng P, Q na points and yung curve na y. Yung problem natin dito is gusto nating mag-define ng slope ng tangent line to the graph of f at P. So, itong line na to which we denote by T. Ayan. So, start tayo doon sa given. So, kung meron kasi tayong point dito na P and Q, when we connect these 2 points, makaka-generate tayo ng second line. And kapag meron tayong line, makaka-generate tayo ng or mako-compute natin yung slope niya, which is just rise over run or the change in y over the change in x or si f of x minus f of x naught over x minus x naught. So, if we denote the slope of this tangent line as m sub sec, equal lang siya dito, no, kay f of x minus f of x naught over x minus x naught. So, yung next na gagawin is, gusto nga natin, paano natin i-define itong slope nitong line na to. So, si P dito, i-fix natin, then si Q, move natin siya towards P. So, papalapitin natin ng palapitin si Q kay P. Yung second line natin dito, palapit din ng palapit kay P hanggang sa ma-generate natin itong line T na ito. Ayan. And if we do that, yung slope din ng mga second line na ina-approach si P, ina-approach niya rin yung tangent line na to or yung line T natin or yung slope ng line T natin. So, this is just equivalent to saying that the limit of the or kapag tinake natin yung limit nung second lines, equal lang siya doon sa slope. Tinake natin yung slope or yung limit ng slope ng second line, equal lang siya doon sa slope ng tangent line natin, which is itong next. Ayan. So, yung slope lang ni line T is just equal to the limit ng mga slope ng second line natin, which is f of x minus f of x naught over x minus x naught. And we denote this by m sub tan. Ayan. And yung line T na to, ito si T kanina, ito yung tatawagin nating tangent line to the graph of f at P. And here's the formal definition. Ayan. So, suppose the function f is defined on an open interval containing x naught. So, the tangent line to the graph of f or y equals f at the point P is the line passing through P having the slope m sub tan given by this equation. So, m sub tan equal lang siya sa limit ni f of x minus f of x naught over x minus x naught as x approaches x naught. Since kapag pinalapit natin ng pinalapit si Q kay P, so makita natin na si X, palapit din siya ng palapit kay X naught. Ayan. And kung pinapahanap naman sa atin ngayon yung slope or yung equation ng tangent line having this slope, gagamitin lang natin yung point slope form of an equation of a line given by this equation. Si y minus f of x naught equal lang siya kay m sub tan times x minus x naught. Ayan. So, na-define na natin ngayon si tangent line. And dun sa ibang textbooks, meron pa silang ibang notation, no? Ayan. So, nilet nila na si delta x or kung minsan ito is si h, which is just the change in x, equal siya kay x minus x naught. So, kapag transpose or kapag kinuha natin si x dito, transpose lang natin si x naught, then we'll have x equals x naught plus delta x, and yung expression natin for the slope of the tangent line becomes this equation. So si m sub tan equal lang siya kay f of x naught plus delta x minus f of x naught over delta x as the limit or the limit nito as delta x approaches 0. So here, as x naught approaches or as x approaches x naught, si delta x dito, ina-approach niya si 0. Ayan. So ito yung isa pang definition for the tangent line. And yung tanong ngayon is, paano natin to may co-connect sa rate of change or sa derivative. So from this figure, so x naught to, ayan, x naught tong mga to. From this figure, makita kasi natin na si x naught, kapag palapit or pag si x naught dito, palapit siya ng palapit kay x naught plus, baliktad, sorry. As x changes, then si x naught plus delta x, palapit siya ng palapit kay x naught. And si f of x natin dito, nagbabago din siya, no, from delta x to x naught plus delta x. Ayan. And makita natin na pag kinuha natin yung ratio nito, si x naught, f of x naught plus delta x minus f of x naught to the ratio of the delta x or si x naught plus delta x minus x naught, yung makuha lang natin is, this is the so-called average rate of change of a function over the interval delta x, x naught plus delta x. Ayan. So, na-relate na natin ngayon si slope of the tangent line sa, or actually this is the slope of the second line. So, na-relate natin yung slope of the second line doon sa rate of change or the average rate of change. And kapag kukunin lang natin yung limit nitong average rate of change natin, makuha naman natin si instantaneous rate of change of a function f with respect to x at x naught, which is just this equation. Si limit ni f of x naught plus delta x minus f of x naught over delta x as delta x approaches 0. That is provided that this limit exists. So, balikan natin yung example natin kanina about kay maglev. Ayan. So, in a test run, engineers have determined that the position S of the maglev measured in feet at any time t given by S equals f of t equals 4t squared. Ayan. So, ito yung position function ng ni maglev or ng maglev train natin from t equals 0 to 30. Ayan. Pinapanap sa atin ngayon yung average velocity and then instantaneous velocity of the maglev at time t equals 2. So, kailangan lang natin dito si f of 2 plus h or 2 plus delta x minus f of 2 over delta x. Ayan. Or, alam kasi natin na yung average velocity equal lang siya sa change in position over change in time. So, para mahanap natin tong average velocity, gagamitin lang natin yung nakuha nating equation. So, denote natin sa average velocity as V average. And equal lang siya sa slope nung second line or nung average rate of change, which is CF of, dito T yung ginamit. So, gawin nating T plus delta T minus F of T over delta T. Ayan. And yung pinapahanap sa atin is at time T equals 2. So, ito is T naught na lang para consistent tayo doon sa notation. So, si T-naught natin dito is si 2. So, we have f of 2 plus delta t minus f of 2 over delta t. And yung makuha natin dito, since si s natin dito is equal to f of t, which is equal to 4t squared. So, si 2 plus delta t equal lang siya kay 4 times 2 plus delta t squared minus 2 f of 2, which is 4 times 2 squared. Ayan, over delta t. So, expand lang natin, makukuha tayo dito ng, ito is square natin yung nasa loob. So, we have 4 plus 4 delta t plus delta t squared minus 2 squared is 4 times 4, so 16 over delta t. So, we have 16 plus 16 delta t plus 4 delta t squared minus 16 over delta t. So, magka-cancel yung 16 dito. Then, si delta t din doon magka-cancel. So, yung matitira lang sa atin is just 16 plus 16 delta t. 16 plus 4 delta t. Ayan. So, ito yung average velocity niya at time equals 2. So, paano naman ngayon yung instantaneous velocity nung maglev? So, kunin lang natin dito yung limit nitong average velocity. So, we have, denote natin siya as v, itong instantaneous velocity. So, kaya merong parenthesis dito, no? Kasi itong instantaneous kung minsan ino-omit na siya. So, rate of change yung tawag lang kung minsan. So, dito is si v, denote natin siya, yung instantaneous velocity natin is denote natin siya as v. So, equal lang siya sa limit as t approaches or as delta t approaches 0 ni f of 2 plus delta t minus f of 2 over delta t. Pero ito is nakuha na natin, which is si 16 plus 4 delta t. So, we have the limit as delta t approaches 0 ni 16 plus 4 delta t. And this is just equal to 16. Yung dimension natin dito is feet per seconds. Ayan. So, gamit yung definition natin ng rate of change and yung instantaneous rate of change, we have here that the average velocity or nakuha natin yung average velocity and yung instantaneous velocity ng maglev at time t equals 2. Ayan. So, yung tanong ngayon is, paano naman natin to may re-relate sa mismong definition ng derivative? Actually, kapag pinalitan natin dito si x naught ng x or any number x, then itong function na to yung definition natin ng derivative. Ayan. So, here's the formal definition. So, the derivative of the function f is that function denoted by f prime such that its value at a number x, so any number x na to, in the domain of f is given by this equation in 3. So, si f prime of x equal lang siya sa limit of the f of x plus delta x minus f of x over delta x as delta x approaches 0. So, provided that this limit exists. Ayan. So, for the remark, ito nga yung sinabi ko kanina na yung derivative lang kasi ni f evaluated at x naught. So, we know na ito lang yung slope of the tangent line to the graph of function f at the point x naught f of x naught, or ito yung point P natin kanina. Ayan. And pwede natin tong ma-interpret. Meron siyang dalawang interpretations. Ayan. So, for the geometric interpretation, so yun nga, yung derivative ni f prime kasi, minimeasure niya lang yung slope of the tangent line to the graph of f at any point x f of x. Ayan. So, provided that the derivative exists, and for the physical interpretation, si f prime lang, minimeasure naman niya yung instantaneous rate of change of f at x. So, na-relate na natin yung tatlo. Si slope of the tangent line, si rate of change, and itong si derivative. So, for this figure, ito lang yung sinasabi niya, no? Itong part na to, yung slope of the tangent line. So, ito yung geometric interpretation and yung instantaneous rate of change of f at x, itong part na to. Ayan. So, for some remarks lang ulit, no? Kung si x naught, particular number siya in the domain of f, then si f prime of x naught, or pwede lang natin may rewrite yung definition natin as this. So, si x, papalitan lang natin ng x naught. So, makuha natin tong equation na to, which is just yung equation din lang natin kanina for the slope of the tangent line. And again, kung si delta x natin equal siya kay x minus x naught, then ito is yung kabaliktaran lang nung kanina, yung alternative formula natin is just this. Si f prime of x naught equal siya kay limit of f of x minus f of x naught over x minus x naught as x approaches x naught. And ito lang yung mga ibang notations natin. So, si y prime, dy over dx, d over dx of f of x, and si dx of f of x. Ayan. So, for example, kung gagamitin natin yung definition, paano natin hanapin yung derivative gamit ng definition if f of x is equal to 1 over x? So, ganito lang yung gagawin, no? Gamitin lang natin yung definition, then substitute lang natin itong si x plus delta x, si x doon sa equation natin. So, skip ko na itong example na to. And yung ino-note ko lang siguro dito is, ayun, so, be careful lang siguro dun sa pagsa-substitute kung minsan. Kasi yung isang nakita kong problem sa mga students is kung minsan hindi na nila nakikita or meron silang mistake doon sa pag-substitute or doon sa pag-simplify. Ayan. And consider if x is equal to 2. Ayan. So, compute na natin sa f prime of 2. Pero yung gagamitin is yung isang formula or yung alternative formula kanina, which is ito lang din yung solution. And again, yun, careful na lang doon sa pag-substitute ng mga values and pag-simplify. So, balikan natin yung example natin kay maglev. Ayan. So, the position function of the maglev at time t is, again, ito yung position function niya, which is s equals to f of t equals 4t squared, where t is greater than or equal to 0, less than or equal to 30. So, pinapahanap ulit sa atin dito yung velocity v at any time t naman. So, kanina yung specific na example natin is t equals 2. Paano naman ngayon kung anytime t yung pinapahanap? So, gamitin lang natin ulit, or alam kasi natin na yung velocity is just the instantaneous rate of change, or it's just the derivative, which is, pag gagamitin natin yung limit definition, so denote ulit natin to as v. Equal lang siya sa v of t na lang. Sa limit as delta t approaches 0 ni f of t plus delta t minus f of t over delta t. Ayan. And pag substitute natin dito yung itong mga values, or at t plus delta t, yung f of t kasi natin magiging 4, wait, may limit. So, pinapakuha sa atin yung limit as delta t approaches 0 ni f of t plus delta t, which is just 4 times t plus delta t squared. So, same lang to doon sa example natin kanina, pero this time kasi is in terms of t na yung inaanap natin. Kanina is particular na 2 yung kinukuha natin. And pag simplify natin ulit ito, we'll have 4 times t squared plus 2t delta t. So, ito yung isang napapansin kong problem sa mga students. Kung minsan hindi nila nakikita yung t dito, So, nasulat lang nila is 2 delta t. So, minus 4t squared over delta t. Ay, nag-move. Sorry. Ayan. So, ilagay ko lang dito sa baba. Simplify lang natin to, makakuha tayo dito ng distribute lang natin si 4. So, we have 4t squared plus 8t delta t plus 4 delta t squared over, mayroon pang minus 4t squared over delta t. And magka-cancel dito si 4t squared and minus 4t squared. Then, yung matitira lang is 8t delta t plus 4 delta t squared. And pwede nyong isulat pa yun or pwede nyong i-cancel na agad si delta t since pwede nating may labas dito si delta t sa taas. So, we have limit as delta t approaches 0 of 8t plus 4 delta t. And as delta t approaches 0, yung matitira lang sa atin is si 8t. So, ibig sabihin, itong velocity natin at any time t is just equal to 8t. And kapag kinuha ulit natin dito yung time t equals 2, then makakuha tayo ng v of 2 which is just equal to 8 times 2 which is just equal to 16 feet per second squared. And consistent naman to doon sa nakuha natin kanina. Ayan. Pero yung sagot dito is si v of t equal siya kay 8t. Ayun. So, pinapakita ko lang yung or kung paano gamitin tong limit definition para makuha yung velocity natin. So, ito kasi yung graph niya. Ayan. So, again, yung interpretation lang nito is siya yung slope of the tangent line. So, at point 216 and siya rin yung instantaneous rate of change. Ayan. Which is yung velocity natin. Itong red na to yung si v of t equals 8t. So ngayon, proceed naman tayo sa differentiability and differentiation rules. So far, na-define na natin si derivative. So gamit yung slope of the tangent line and na-relate din natin siya sa concept ng rate of change. So, kailan ba hindi magiging differentiable or hindi mag-exist yung derivative natin? So si derivative kasi is just na-define siya gamit ang limits. And yung limits, pwede siyang hindi mag-exist. So, ganun din. So, yung derivative natin, pwede rin siyang hindi mag-exist. So, define lang muna natin tong tinatawag nating differentiable. So, a function f, differentiable lang siya at x1 or at point x1 if yung derivative at that point exists. Ayan. And differentiable din siya on an open interval kung differentiable siya at every number on the interval. And meron pang isang definition na kung differentiable siya from negative infinity to infinity or dun sa real number line, then differentiable everywhere siya. So, and meron din tayong theorem na kung si f differentiable at x naught, then f is continuous at x naught. So, nai-relate din natin tong differentiability sa continuity. So, take note na differentiability implies continuity, but continuity doesn't imply differentiability. Pero nagwo-work yung contrapositive nito, no? Which is kung si f discontinuous at x naught, then si f differentiable siya kay x naught. So, tulad nung sinabi ko kanina, kailan ba hindi mag-e-exist yung derivative? So, usually merong tatlong case. Ayan. So, kung meron tayo ditong corner, ayan, at this point, A, and kung meron tayong discontinuity, ayan, dahil dito sa contrapositive ng theorem na to, and kung meron tayong vertical tangent line. So, pwede rin nyo rin itong may relate sa slope ng tangent line, no? So, dito sa part na to kasi, yung limit natin, ina-approach. Since yung derivative natin is equal to limit, yung limit kasi natin dito is hindi siya mag-i-equal. Yung limit from the left and yung limit from the right. Ayan. And dito sa part ng vertical tangent line, yung slope nung limit natin dito or yung slope of the tangent line here will be equal to infinity. Ayan. And syempre itong discontinuity, magfo-follow siya dito sa theorem. So now, tulad yan medyo paulit-ulit na po ako, no, sorry. So yung derivative kasi mahaba yung definition niya. So meron din tayong mga tinatawag na differentiation rules para mapaiksi or para ma-simplify natin yung paghahanap ng derivative. So ito siya, no. So wait, excuse lang po saglit. Sorry. Ayan. So ito yung differentiation rules natin, which is gagamitin natin to simplify or in simplifying yung paghahanap nga ng derivative. So i-let natin dito na si f and g, differentiable function siya, and si c, any constant. Ayan. So yung first na rule natin is yung tinatawag natin na constant rule. Ito lang yung sinasabi niya. Kung si f natin dito equal to c, which is some constant, then si f prime of x laging equal siya kay 0. So si c dito is any number lang. Ayan. Or any real number. So pwedeng maging negative number, positive number, rational, irrational. So equal, yung derivative niya equal parati sa 0. So yung next na rule is yung tinatawag nating power rule. So kung given naman tayo ng equation na x to the n, where yung n natin dito is in R, so kung minsan tinatawag tong general version ng power rule since yung n natin dito is any reals. Ayan. Then yung derivative lang niya is just equal to n times x to the n minus 1, or decrease natin by 1 si x times yung original na exponent natin, which is n. Ayan. So yung next na rule is yung tinatawag natin constant multiple rule, which is just kung yung function natin equal siya kay some constant times some function or c times g of x, then yung f prime of x natin equal lang siya dun sa constant then times nung derivative nung function. Ayan. And yung next na rule is yung sum and difference rules. Or si sum rule dito is kung meron tayong function or sum ng dalawang function, then yung sum lang nung derivative niya is just equal to the sum of the derivatives. Ayan. So si f of x plus g of x, yung derivative niya equal lang siya kay f prime of x plus g prime of x. And yung sa difference, ganun din. Si f of x minus gx, yung derivative niya equal lang siya kay f prime of x minus g prime of x. Ayan. And pwede natin tong i-extend up to a finite number of terms, ayan, or functions. And take note na dun sa difference, ayan, since minus yung pinag-usapan natin, nagmamatter dito yung order nung terms. Pero dun sa addition, okay lang kahit na magpalit-palit siya. So for the next rule, we have the product rule. So kung si h dito equal siya sa product ng dalawang functions, then ito yung magiging derivative niya. So h prime of x, kunyari equal siya kay f of x. Ayan. So the left function. So si f kasi dito tinatawag natin tong minsan na left. Tapos si g naman yung right function. So yung derivative lang nitong yung product ng dalawang functions na to, equal lang siya sa left times yung derivative ng right function plus the derivative of the left function times the right function, or yung mnemonic para dito is left the right or derivative ni right plus the left or derivative ni left times right. Ayan. So left the right plus the left right. And since addition tong operation natin dito, hindi rin nagma-matter yung order nitong terms. Pero para mas madali siyang ma-memorize, ayan, so stick na lang tayo dun sa mnemonic natin na left d right plus d left right. Ayan. And take note na or yung derivative nitong h natin, which is si f times g, yung derivative niya is hindi ito dapat mag-equal sa f prime of x times g prime of x. So sa h prime of x, hindi siya equal kay f prime of x times g prime of x. So ito kasi yung isang pang napapansin ko sa ibang student, so wala dapat yung isang ano doon. Ginagawa nila is si f prime times g prime. So hindi yun yung rule or yung derivative nitong product ng two functions, kundi itong expression na 'to. Ayun. And lastly, meron tayong tinatawag nating quotient rule or yung derivative naman ng quotient ng two functions, where si g natin dito is not equal to 0, yung denominator natin dito dapat hindi mag-equal kay 0 para mag-exist din yung derivative and maging defined 'tong quotient natin. So, ito naman yung magiging derivative kapag quotient. So, we have here si f naman dito, yung tatawagin nating high function or yung nasa taas, high, tapos si g natin yung tatawagin nating low. So, we have here low times derivative ng high minus high times derivative ng low over low squared. Ayan. Or yung mnemonic dito is low d high or derivative ni high. So, low d high minus high d low over low low or low squared. Ayun. And dito, tulad nung ginawa natin sa product rule, hindi kasi equal yung derivative niya, hindi siya equal sa derivative lang nung function sa taas over the derivative on the denominator. Ayan. So, hindi ito mag-equal dito. And itong mga rules natin na to, pwede natin siyang ma-prove gamit yung limit definitions natin. Ayan. So, hindi ko na siya ipapakita dito. So, ito lang yung mga rules natin. And some examples. Ayan. So, ditong first, madali lang siya since constant function. So, makuha natin agad dito na si f prime of x equal siya kay 0. Ito ring second, gagamitin lang natin dito si power rule. Ayan. And again, pag sinabi nating power rule, susulat lang derivative ni x to the 6. Mag-equal lang to kay 6 times x to the 5 or yung original exponent times yung function na na-decrease ng isa or decrease by 1. Ayan. Itong third, usually yung ginagawa dito is nire-rewrite muna siya in terms of power. So, si f of x equals 1 over x kasi equal lang siya kay x to the negative 1. Then, gamitin ulit yung power rule. So, makakuha tayo dito ng negative 1 times x raised to negative 1 minus 1, which is negative 2. Equal lang siya kay negative 1 over x squared. Ayan. So, yun yung isa pang technique usually kapag meron tayong ganitong form or kung minsan meron tayong square root, nire-write muna natin siya, no, na in terms of nung power niya. Ayan. And for the next example, ito actually yung position function nung maglev natin, and pag kinuha natin yung derivative niya, this is a combination of the constant multiple rule and the power rule. So we have here 4 times, gamitan ng power rule si x squared, so we have 4 times 2x, equal lang to kay 8x. Ayan. So consistent pa rin naman tayo dun sa nakuha natin kaninang gamit yung limit definition, which is equal to 8t. So, for the next example, we have f of x equals 2x cube. Ayan. So, yung gagawin natin dito is i-simplify muna natin siya. So, si 2x cube kasi equal lang siya kay 2 cube times x cube. So, this is equal to 8x cube. Then, saka natin kunin yung derivative niya, which is equal to f prime of x. So again, ito is similar lang sa example 4, which is a combination of constant multiple rule and the power rule. So we have here 8 times 3, which is 24. Then x cube minus 1, which is 2. So yan, so x squared. Equal siya kay 24x squared. So yung common mistake dito is, yung ginagawa ng iba, gumagamit na agad sila ng power rule sa part na to. That is, kung ginamitan kasi ito ng power rule, so bababa natin yung exponent or yung original exponent times yung nasa loob, which is 2x. Then, raise kay 2. Ayan, so ganito yung ginagawa nung iba. And this is not equal to f prime of x since si 3 times 2x squared, ito is magiging 6 times 4x squared. 3 times 3 times 4x squared, which is equal to 12x squared. Ayan. So, dito kasi hindi pa natin ini-introduce yung isang rule na pwedeng gamitin para diretso na gamitin ito, no? Ayan. So, doon sa basic rules, be careful lang din doon sa kung anong rule yung gagamitin natin. So, itong next na examples, medyo same lang din. Ito is difference lang. Gagamit tayo dito ng difference rule, power rule, and constant multiple rule. Itong next naman is the product rule. Ayan. So, yung isang technique dito is pwede natin siyang, kung ganito lang din naman yung equation, pwede natin siyang i-distribute muna, then saka gamitin yung ibang rules, or pwedeng gamitan na siya agad ng product rule, which is just left d right plus d left right. Ayan. So, for this example, hindi ko na siya gagawin. Gagamitan lang din ito ng quotient rule. Ayan. Which is low D high minus high D low over low low. And itong last na example, yung isang ginagawa ng mga students is, pag nakakita kasi sila ng rational form or nung ganitong form, no, na merong numerator at denominator, ginagamitan agad nila ng quotient rule. Pero dito, pwede muna nilang i-simplify ito. Since pwede natin itong may rewrite as 1 over cube root of x squared plus x squared over cube root of x squared. Ayan. And ito is, again, pwede natin siyang itong first na term, pwede natin may rewrite in terms of its power. So, we'll have here x raised to negative 2/3. Itong next naman is, pwede mag-cancel si x squared and si cube root of x squared. So, we'll have here x squared minus x raised to negative 2/3. So, x raised to 2 minus 2/3. So, we have x raised to negative 2/3 lang ng 4/3. Ayan. Then, ito na yung gamitan natin ng technique or nung basic technique, which is mas madali lang since magpa-power rule lang kayo dito. Ayun. So, ito yung para sa mga techniques. So, ayan. So, meron pa tayong ibang derivatives naman. So, derivatives for the trigo, natural log, and exponential function. So, for the derivatives of the trigo, so yung derivation kasi dito nung derivative ni sine and ni cosine, gagamit tayo dito nung mga limits. Ayan. So, yung mga known na limits dito is yung na-discuss kahapon about dun sa limit kay sine and yung limit ni cosine. And kapag alam na natin itong limit ng dalawa, pwede na nating ma-derive itong ibang kung alam natin yung derivative nitong dalawang function, pwede na nating makuha yung derivative ng ibang function. And dito, kunyari kay tan x kasi, pwede natin siyang may sulat as sine over cosine. Ayan. And Pag kukunin natin yung derivative niya, gagamitan lang natin siya ng quotient rule. Then, made-derive na natin itong si secant squared x. Ayan. And, yung isang ino-note natin dito is kung nag-start sa letter C, yung trigo function natin, laging negative yung, dapat may negative din to. Laging negative yung derivative niya. Ayan. So, kung minsan, kung hindi to kabisado ng mga student, and alam naman na nila yung basic na techniques ng differentiation, then kahit itong dalawa lang yung sure sila or yung makukuha nila, no? Anyway, si sine equal lang na, yung derivative ni sine equal lang naman siya kay cosine x, and si cosine x equal lang siya kay negative sine x. So, medyo madali lang siyang i-memorize. Then, kahit ito lang yung dalawang alam nila, pwede nilang ma-derive tong ibang function gamit tong derivative nitong sine and cosine. Ayan. And yung derivative naman ni e to the x equal lang siya parati sa sarili niya. And si ln x, yung derivative naman niya, equal lang siya sa 1 over x. Where si x dapat dito is greater than 0 para maging define tong ln and itong derivative. So, kasi alam na natin si f, and alam din natin si f prime. And actually, pwede pa nating makuha yung derivative pa ni f prime or ni y. Ayan. So, ito lang yung mangyayari, no? Pwede kasi nating makuha yung derivative ni f, derivative ni f prime, derivative ni f double prime, and so on hanggang sa nth derivative. And ito lang yung mga notations para doon. So, first derivative, equal lang siya kay y prime, f prime, and so on. Second derivative, equal lang siya sa derivative ng first derivative, which is y double prime. Ayan. And yung third derivative naman, equal lang siya sa derivative ni second derivative or nung second or dalawang beses yung i-derivative si first derivative para makuha si third, and so on hanggang sa makuha natin si nth derivative, which is just y to the n. Ayan. So, yung example nito is kung babalikan natin yung motivation natin. Ayan. So, kung meron tayong position function s, again, yung velocity natin dito is just the first derivative of the position function. And pwede rin kasi natin makuha si acceleration denoted by a of t. So, differentiate lang natin si velocity. Ayan, so we have a of t equal siya sa first derivative ni velocity or twice na differentiate si position function s of t. So, we have a of t equal siya kay s double prime of t. And kung minsan, meron pa yung tinatawag nilang sa physics na jerk, which is yung third derivative naman ni position function or yung derivative lang ni a of t. So, denoted siya by j of t. Equal siya sa first derivative ni acceleration. So, pag relate natin itong jerk sa velocity function, so twice lang natin i-differentiate si velocity, and kapag kay position function naman, thrice nating i-differentiate si position function para makuha natin tong jerk. Ayan. So, ito kasing higher derivatives, yung nakita na natin yung application niya noong noong Thursday, doon sa talk ni Sir Jonas. Ayan. Which is yung sa polynomial approximations. Ayan. So, pwede siyang gamitin doon. And yung second derivative, pwede rin siyang gamitin sa application na optimization. Ayan. Or yung sa concavity nung graph. So, for the next rule, meron tayong tinatawag na chain rule. Ayan. So, without the chain rule, itong mga functions na to, pwede nating makuha agad yung derivative niya gamit lang yung basic differentiation techniques. So, paano naman kung i-rewrite natin itong functions natin as itong mga nasa right? Ayan. So, kunyari si y equals 3x plus 2, erase natin siya sa 100. Si x squared plus 2 is kunin natin yung square root niya. Si sin x, kunin natin yung sin x cube. Si e to the x, magiging e to the cosine x. Si 1 over x naman magiging 1 over 2x plus 1. So, hindi kasi mag-work dito yung basic na integration techniques natin. And yung gagamitin nga natin dito is yung tinatawag nating chain rule. So first ay bago natin i-define tong chain rule, observe muna na itong functions natin na nasa right ay pwede siyang ma-decompose into functions. Ayan. Or this is just a composition of two functions, which is, ayan. Ito yung decomposition niya, no? Kung napansin nyo kanina. So, for example, given tayo nitong first, which is si 3x plus 2, y equals 3x plus 2 raised to 100. So, makita natin na pwede natin siyang ma-decompose into a composite function siya. And yung inner, meron tayong outside function and inside function or outer function or inner function. So yung inner function natin dito, pwede natin siyang i-let na u, which is equal kay g of x. Ayan. And ito, yung inner function niya is, kunyari si 3x plus 2. And yung outer function natin dito is yung naka-raise kay 100, which is, kunyari if we let u yung nasa loob ni f, this is just y equals u raised to 100. Yung next naman, ganun din. So, makita nyo na yung nasa loob o yung magiging inner function natin dito is si x squared plus 1. And yung outer function natin dito is si square root of u. Ayan. And so on. So, paano natin ito masosolve? Gagamitin natin yung tinatawag nating chain rule. Ayan. So, we can think of the composite function FOG in terms of its two parts. So, meron kasi siyang inner and outer part. So, ito yung sinabi ko kanina, yung outer function, si F, and yung inner function natin dito is si G. Ayan. And kung i-let natin si U na G, then makakuha tayo dito ng F of U, which is same lang. Yung outer natin dito is si F parati, and yung inner natin is si G. So, dito sa notation na to. Sa ibang books kasi is pinagbabaliktad nila, no? Pero ito na lang yung gamitan nating notations. So, para makuha yung derivative ng ganitong klaseng function or composite function, yung rule dito is, kukunin muna natin yung derivative ni f or yung derivative ng outer function times the derivative of the inner function. Ayan. So, kung i-let natin si u as the inner function, then ito yung rule natin, no? Si y prime equal lang siya sa derivative ng outer function at u or at the inner function u times the derivative of the inner function. So, we have y prime equals f prime of u times u prime. So, kung babalikan natin yung example natin kanina, or ito yung formal na theorem to describe the chain rule. Ayan. So, if y is equal to fu is a differentiable function, so dapat differentiable dito si f natin and si g. So, differentiable function siya of u, tas si u naman is differentiable function of x, or si g of x, differentiable function of x, then y, which is just equal to the composite FOG, is a differentiable function of x dapat. And ito nga yung sinabi natin kanina, si dy over dx, so Leibniz notation lang to, equal siya sa dy over du, so ito si f prime of u natin, times du over dx. Ayan. Or equivalently, yung derivative lang ni f of g of x, equal siya sa f prime of gx times g prime of x. Where si g of x natin dito, usually is nilet nating u. Ayan. So, ito is magiging u prime. Ayan. So, kung babalikan nga natin yung example natin kanina, ito, dun sa first, paano yung gagawin natin dito. So, yung inner function again natin dito is si 3x plus 2, and yung outer function natin dito is si u raised to 100. So, we have here, so, itong first example lang gawin natin since wala nang time. So, kunin lang natin si derivative ni outside function. Ayan. So, yung derivative ni u raised to 100 is just 100 times u. Or yung u kasi natin is si g of x, which is si 3x plus 2. So 100 times 3x plus 2. So gagamitan to ng power rule. So we have 100 minus 1 which is 99 times the derivative of the inner function. So hindi derivative ng inner function natin is just 3. Ayan, since si 2 constant, so magzi-0 lang yung derivative niya. And ito is gagamitan ng constant multiple rule and power rule. So we have here times 3. So simplify lang natin, makuha tayo dito ng 300 times 3x plus 2 raised to 99. Ayan, so ito yung derivative na nung composite function natin na y equals 3x plus 2 raised to 100. So for the other examples, so exercise nyo na lang po ito since wala ng time. Ayan. So again, kapag gumagamit ng chain rule, yung rule lang parati dito is derivative of the outer function times the derivative of the inner function. Ayan, or yung inside-outside rule na tinatawag. And kapag i-relate na ulit natin to sa rate of change, yung sinasabi lang ng chain rule is yung y natin dito or si f of g of x natin changes dy over du times as fast as u. And si u naman nagche-change siya du over dx times as fast as x. So yung y natin dito nagche-change siya dy over du times du over dx times as fast as x. So makita natin siya dito sa diagram. Ayun. So meron din tayong tinatawag na implicit differentiations kasi usually yung mga functions natin pwede nating maisulat in the form y equals f of x. So ito yung tinatawag nating explicit form ng function. And kaso merong mga ibang equations or functions na or equation na lang, merong ibang equations na hindi natin may susulat explicitly in terms of y. So for example, kunyari meron tayong x squared plus y squared equals 1. This is an implicit function of x since meron tayong x values dito which correspond to 2 y values. And si y hindi siya function of x doon sa, dito kasi is a circle centered at the origin with radius 1. So this function, hindi siya function on the whole circle since ganito yung itsura niya. Ayan. And however, pwede kasi nating ma-solve si y or doon sa example na yun, pwede pala nating ma-solve si y in terms of x. So we just have y equals plus minus square root of 1 minus x squared. Ayan. Si y equals 1 minus x squared, ito siya, yung top half of the circle, and si y equals negative, dapat to, negative square root of 1 minus x squared naman yung bottom half of the circle. Ayan. So, magkaibang function sila kung hinati natin. So, dito sa example na to, pwede nating may sulat si y in terms of x, no? Pero marami pa kasing ibang equations na mahirap isulat si y na in terms of x or mahirap makuha yung explicit form nung equation. So, for example, ayan. So, meron tayong equation of a curve na tinatawag nating volume of Descartes and ito yung equation niya. Si x cubed plus y squared equals 3xy. So sa ibang textbook, 6 yung ginamit dito. 6 yung ginagamit dito pero similar lang din naman na volume of Descartes yung tawag sa kanya. Basta ganito yung form niya and ito is makikita natin na implicitly na na-define yung y natin as a function of x. Ayan. Since kapag ito kasi yung graph ni x cubed plus y cube equals 3xy or ni volume of Descartes. And kapag hinati-hati natin ito, graph niya, ayan, so pwede tayong makuha ng iba't ibang graph na in terms of x or functions siya in terms of x kapag nahati, tulad nung sa circle kanina. So, paano natin kukunin yung derivative ng ganitong type of function? So, meron tayong guidelines. Ito siya. So, first, differentiate muna natin yung both sides of the equation with respect to x. Then, collect the terms involving dy over dx. So, makakuha kasi tayo later ng function or kapag kinuha natin yung derivative nito, makakuha tayo ng expression na dy over dx. Then, collect lang natin yun doon sa left side and move natin yung ibang terms na walang dy over dx doon sa right side. Then, factor out natin si dy over dx. Then, pwede nating ma-solve si dy over dx. And yun na yung magiging derivative ng equation natin or yung tinatawag nating implicit differentiation. So, for example, balikan natin yung, ayan, so pinapanap sa atin yung derivative or si dy over dx ni volume of Descartes, which is x cubed plus y cubed equals 3xy. So, pag gagamitin natin yung step by step, ayan, so kunin lang muna natin yung derivative, both sides with respect to x. So, yun yung step 1. Then, simplify lang muna natin. So, we have here the steps, no? So, kapag kinuha kasi natin yung derivative nitong si x cubed plus y cubed, equal lang siya sa 3x squared plus 3y squared times yung derivative ni y. Ayan, with respect to x. And yung kabila naman, pag kinuha natin yung derivative with respect to x, so makakuha tayo dito ng product, parang product of two functions. Ayan, so we have 3x times yung derivative naman ni y with respect to x plus yung derivative dito ni x times 3y, which is 3y lang. And pwede nating ma-cancel out dito si 3, so we have x squared plus y squared. dy over dx equal siya kay x, dy over dx plus y. So, for the second step, pagsamahin lang natin yung mga merong dy over dx sa isang side, then lipat yung mga wala dun sa kabilang side. So, dito yung merong dy over dx ay si y squared and si minus x or negative x. Then, simplify ulit natin. Factor out lang natin si dy over dx para sa step 3. So, we have y squared minus x times dy over dx. Equal lang siya kay y minus x squared. Ayan. Then, solve for dy over dx. So, we have dy over dx equal siya kay y minus x squared over y squared minus x. Ayun. So, yun lang yung gagawin kapag implicit differentiation. So, ito naman yung ibang derivatives ng ibang transcendental function. So, itong mga to is pwedeng ma-derive gamit yung chain rule and yung implicit differentiation. Ayan. So, excuse lang po ulit. So, proceed na tayo sa applications ng derivative. So, i-consider ko lang dito is related rate. So, hindi ko na dahil sa time constraint, hindi ko na madi-discuss yung sa optimization. So, given tayo ng problem na to. So, actually, this problem is, or basahin lang muna natin itong problem. So, one rainy day, a girl broke up with her boyfriend after being together for 8 long years. So, they decided to separate at the place where everything about them began at the same time. So, the boy is due north crying and running at a rate of 5 feet per second, and the girl is walking due east at a rate of 1 feet per second, thinking if she made the right decision. So how fast are they separating from each other 5 seconds after they started moving to a new life without each other? So kung meron tayong related rate problems, first is kailangan nating, or ito is example lang ng isang application sa derivative, no? And actually, this problem is, kaya ito yung pinakita ko kasi nag-viral ito online kung nakita nyo siya sa Facebook. And galing kasi itong problem na to dito sa UPB. Actually, stolen photo to sa isang klase ni Ma'am Olive. Which is as I was saying, nag-viral kasi ito and stolen photo to sa isang math class dito sa UPB. Ayan. And itong problem I think is galing din or gawa din ng mga instructors dito sa UPB. Ayan. So, pag given tayo ng ganitong problem, paano yung gagawin natin? So, i-define lang muna natin kung ano ba 'tong sinasabi nating related rate. So, yung pwede kasi nating gamiting techniques 'pag given tayo ng related rates problem or rate of change problems is the implicit differentiation, ayan. And kung minsan is pati rin si, chain rule. And yung typical setup kasi dito is meron tayong quantities x and y na nagde-depend siya dun sa third quantity t. And si t usually dito is in terms of time. And suppose na alam natin yung relationship between x and y in the form of an equation. So yung problem sa atin dito is paano tayo makahanap ng relationship between the related rates dx over dt and dy over dt. Or kung kunin natin yung rate of change ni x with respect to t and yung rate of change with respect to y. So, some examples lang of mathematical models na nag-i-involve sa rates of change. So, ito meron tayong kunyaring verbal statement, then ito yung mathematical model niya. So, pwede siya sa iba't ibang applications, pero dito yung kinonsider ko lang kasi is yung applications niya sa motion or sa velocity and position. Ayan. So, balikan natin ngayon or ayan. So, bago natin sagutan, sorry, yung problem, ito yung guidelines for solving related rate problems. Ayan. So, first, meron pa tayo ditong step 0. Of course, basahin muna nating mabuti, intindihing mabuti yung problem. Ayan. So, sa step 1, identify all given quantities and the quantities to be determined. And if possible, gawa tayo ng sketch and label yung quantities. Ayan. So, for the next step, sulat natin yung equation involving the variables whose rates of change either are given or are to be determined. Ayan. And for the third step, gamit din natin si chain rule. That is, implicitly differentiate natin yung both sides of the equation with respect to time t. And for the last step, so after completing step 3, substitute natin doon sa resulting equation yung lahat ng known values for the variables and the rates of change. And pati na rin yung mga na-derive nating values. Ayan. Then solve for the required rate of change. So, gamit tong steps na to, solve natin yung nag-viral na math problem. Ayan. So, basahin ko lang ulit or sige, since wala ng time, so gamitin na natin or solve na natin siya agad. So, analyze muna natin. So, meron kasing tayo ditong dalawang object, no? Kunyari si girl and yung ex na boyfriend na niya. Ayan, since break lang nila dito sa problem. And yung lalaki dito or yung boy, due north siya at rate 5 feet per second. And yung girl naman is due east at rate 1 feet per second. So, yung problem sa atin dito is gaano sila kabilis o yung rate of change of the separation after when time is equal to 5 seconds. Ayan. So, gamitin natin yung steps. Yung first na step is identify all the given quantities and quantities to be determined. So, I think hindi yata magkakasya dito yung so, gamit na lang po ako ng notepad. Nakita po ba yung notepad ko? Yan. Nakita po ba yung na-share na screen? Ayan. So, for the first step, i-let muna natin or isulat lang muna natin yung mga known na values or known na quantities. So, let natin dito si t as time. Let t be equal to the time or number of time. let natin dito si x as yung distance. Distance nung boy na lang. So, distance traveled by the boy. And si y yung distance traveled by the girl. And si z naman yung distance of separation. Or yung distance of separation or yung distance between them. So, pag i-sketch kasi natin itong problem, ganito yung magiging itsura niya. So, si boy is due north at 5 feet seconds. So, kung kunyari dito yung starting point, yung boy is due north. So, dito siya sa taas. So, kunyari dito, lang natin ng B. And si girl naman is walking due east. So, dito siya sa right side or sa east natin. So, kunyari ito si girl. And yung problem is pwede natin siyang, si boy kasi papunta siya doon. And si girl is papunta siyang east. And pwede nating may relate tong problem na to, or yung pinapahanap kasi sa atin is yung distance between them, which is itong part na to. And kung makita nyo, meron tayong mabubuo ditong right triangle. So, kung i-let natin dito na si x yung distance na traveled by the boy. So, ito si x. Si y yung traveled by the girl. So, dito si y. And yung distance of separation, which is ito, dapat dito si z. Ayan. So, yung next na kailangan natin isulat is yung mga known na quantities ulit, no? So, alam natin yung rate nung boy or yes, tama, yung rate nung distance or yung velocity nung boy which is just dx over dt equal siya kay 5 feet per seconds. Alam din natin si dy over dt or yung rate of change sa distance which is 1 feet per second. Ayan. And pwede rin natin ma-solve dito si x and y. Since alam natin na yung distance equal lang siya sa velocity times time. Ayan. So, pag sinolve natin si x and y, mag-equal lang siya sa x times yung distance which is si dx over dt or si 5 feet per second times 5. Or at when t is equal to 5, masosolve natin yung distance. Ayan. So, si x equal lang siya kay 5 feet per second times 5 seconds. 2 seconds. So, si x or yung distance traveled by the boy is just 25 feet since magka-cancel out dito yung seconds. Ayan. Si y naman or yung distance traveled by the girl, makakuha tayo dito ng 1 feet per second times 5 seconds. So, we have here y equals 5 feet. So, nakuha na natin itong values or itong mga pwede nating ma-derive na values mula doon sa given. Now, paano natin may relate ngayon yung problem or yung need to find kasi natin dito is si dz over dt or yung rate of change nung distance as they move away from each other. Ayan. So, si dz over dt yung hinahanap natin when t is equal to 5. So, given na tayo nitong mga known na equations, so yung next na step na gagawin is, ayan, so kailangan muna nating magsulat ng equation involving the variables. So, notice na meron tayong nabuo ditong right triangle. So, pwede nating ma-relate dito si x and y in terms of z using the Pythagorean theorem, which is, yung Pythagorean theorem lang natin is just equal to x squared plus y squared equal siya kay z squared. And pwede nating isolve na agad dito si z kasi known naman na si x and y dito. So, si z dito is, yung makuha lang nating z is just the square root of x squared plus y squared. And this is just equal to, ito na lang po sa ibaba, square root ni 25 squared plus 5 squared. So, ito is magiging 600 square root of, pwede natin ilabas na lang si 25. So, we have 25 plus 1. And pwede natin labas dito si square root of 25. So, we have here 5 square root of 26. And yung units natin dito is feet. So, nakuha na natin si z. Ngayon. So, yung next na step ay nakuha na natin lahat ng mga kailangan nating values and nakasulat na rin tayo ng equations na nagre-relate doon sa problem natin. So, yung next is gagamit na tayo ng ito si step 2. Si step 1 yung kanina. So, yung step 3 is gagamit na tayo ng chain rule or implicit differentiation para makuha yung kailangan natin na si dz over dt. So, from the Pythagorean theorem of x squared plus y squared plus z squared, so differentiate lang natin both sides with respect to t. Then, we'll have d over dt x squared plus y squared equals to, equal siya sa d over dt of g squared. Ayan. And dito makakuha tayo ng 2x dx over dt plus 2y dy over dt. Equal lang siya sa 2z dz over dt. Pwede natin cancel out si 2. So, we have x dx over dt plus y dy over dt equal siya sa z dz over dt. Ayan. So, magpa-extend lang po ng konti. Malapit na po itong matapos. Then, yung kailangan kasi natin is si dz over dt. So, pwede natin itong isulat as divide both sides by z. So, we have 1 over z ng x dx over dt plus y dy over dt. And substitute na natin yung mga known na values. So, nakuha natin si z which is si 1 over 5 square root of 26. Si x is si 25, y is 5. Then, yung dx over dt natin is 5 and yung dy over dt natin is just 1. So, we have here x is 25. Si dx over dt natin is 5. Si y natin is 5. Si dy over dt natin is 1. Ayan. So, we have 25 times 5 which is 125 plus. Actually, pwede din natin ulit itong i-factor out si 5 na lang. So, we have 5 times 25 plus 1 which is 26 over 5 square root of 26. So, this is equal to 26 over square root of 26. Ayan. And this is, yung units niya is feet per second. So, nakuha na natin ngayon yung problem which is ito yung rate of change or ito ganito kabilis sila naghiwalay or yung rate of change of separation. Si dz over dt ko lang siya sa 26 over square root of 26. So, noong nag-break pala sila, ayan, so ganito sila kabilis na lumayo sa isa't isa, which is approximately 5.1, I think, feet per second squared. Ayan. So, may tanong po ba doon sa problem. So, time na po sakto. Ito po yung last na example ko. And tulad po nung nakita na po ba yung slides ko lang? Ayan. So, mostly yung tinakal ko po dito is yung application sa motion or sa velocity and position function. And ito na po yung last example ko. So, ito po yung references. Ayan. So, mostly itong presentation is based din doon sa discussion or doon sa presentation nung last SINSM which is nung 2019. So, ayun po. And ito po yung mga textbooks and pinag-basean ko rin po yung guide or yung teaching guide in senior high school basic calculus. So, ayan. So, thank you po sa pakikinig and ayun po. Kung may mga tanong po sa chat box na lang po. Thank you po.
Thank you, Ma'am Abermel, for that wonderful talk. Sa mga tanong po, tanong nyo lang po. So may tanong dito galing kay Anita. Kay Miss Anita Parungaw. How does derivatives simplify solving real-world problems?
So, yung derivatives po kasi is rate of change siya, no? So, ayun po. So, marami pa pong applications po yung derivatives, hindi lang po sa actually marami nga po siyang applications po sa real life problems tulad po sa engineering, mostly po sa physics and so on. Puwede rin po siya sa medical science or health sciences. And meron din po sa econ. So, ginagamit po kasi itong derivatives para ma-simplify nga po yung mga real world problems na yun.
Any more questions from the audience, participants? So mukhang wala nang tanong. So sa mga nandito ngayon, you may access the evaluation form for this lecture through the link in the chat box.
Yan. So, thank you po ulit. I-stop share ko na lang 'to.
So may additional, may questions pa pala galing kay Ma'am Shirley Estipular. Is there any specific real-life situation used in derivatives aside from distance or rate?
Yes po. So, puwede kasi po siyang gamitin din sa kunyari po sa econ, ayan. So, puwede pong ma-solve yung change sa or yung mga rate of change po sa marginal cost function, mga gano'n po. And puwede rin po siyang magamit sa engineering. So, usually yung sa mga volumes, yung mga rate of change po sa volumes and so on. Sa ano naman po sa health sciences, puwede po siyang magamit 'no to solve yung yung rate of change po ng population growth, gano'n po.
Thank you ulit, Ma'am April. So yun,
So hindi sige po. Hindi ko po kasi na-discuss dito yung sa optimization na part 'no. So isa rin po yung applications po ng derivatives, ayan. So usually na-optimize po yung cost function, gano'n po yung idea doon. And mina-maximize po yung mga so gusto po nating i-minimize siyempre yung mga loss, ganyan. Tapos i-maximize po yung parang mga wins, parang gano'n po yung idea. Ayun po.
And hello, may tanong pa po ba tayo from the participants?
Okay, so kung wala na po tayong tanong, before we leave, paki-fill out na lang po yung evaluation form, which is nasa may Zoom chat box na natin. And for those na nanonood via live stream, YouTube live stream, nakapin na rin po yung link doon. Ayan. Ayan po, kung tapos na po tayong mag-eval, pwede na po tayong mag-leave and to have our lunch break. And then, yung next lecture po natin is at 1 p.m. this afternoon. Ayan po. So, see you later po. Thank you. Naimbag nga aldaw. Welcome back to the 26th SINSM Mathematics and Computer Science series, Track 8 Pre-Calculus and Basic Calculus. We are now down to our last lecture, not only for today, but for the whole 26th SINSM Track A lecture series. And so before we proceed, may I remind our participants to please um, turn off your microphones and webcam during the talk. Please, the Q&A will take place at the end of the lecture. You may drop your questions in the Zoom chat box or in the YouTube live chat. At the end of the lecture, the link for the evaluation form will be posted. Certificates will be awarded to attendees who attended at least 75% of all the lecture series in this workshop. Okay, so for our last lecture, we will once again hear and learn from Miss Aprimel Pajimola, an instructor of mathematics here at UP Baguio. May we please welcome Miss Pajimola.
Ayan, hello po. Good afternoon po ulit. I-share ko lang ulit yung screen ko. Ang clear mo pa pala yung audio ko? Ayan. Nakita na po ba yung screen ko?
Yes.
Thank
Yes,
you po,
ma'am.
sir. Ayan. So, kung kanina, diniscuss natin yung derivatives, discuss naman natin ngayon itong integration. So, tulad nung tanong ko kanina about sa derivatives, bago tayo mag-start, pwede ko bang, or pwedeng magtanong ulit sa inyo na, for example, kung narinig nyo yung salitang integration naman this time, or integrals or antiderivatives, ano naman yung unang pumapasok sa isip ninyo? Ayun. So, pakidrop na lang po sa chat. So, what comes to mind when you first hear the word integration or integral? Ayan. So, may mga sumasagot na po. Yes. Merong area under the curve, merong volume. Ayan. So, mostly area under the curve yung mga sagot. Ayan. Solid revolution. So, yan. So, actually, kapag integrals, kung yung pag-derive natin kanina ng, or yung pag-define natin kanina ng derivatives ay about sa slope of the tangent line. So, sa pag-derive naman natin ng definition, or for the definition of integration, gagamitin naman natin yung area under the curve or the so-called area problem. So, kanina tangent line problem, ngayon naman area problem yung gagamitin natin. So, let's start. Ayan. So, ito yung outline ng magiging talk ko for today. Ayan. So, hindi ko nababasahin isa-isa. Ayan. So, for the motivation, so, consider ulit natin yung maglev na kinonsider natin kaninang umaga doon sa derivation. So, kunyari, consider this maglev moving a straight monorail track, or straight elevated monorail track. So, kung kaninang umaga, kung given tayo ng position, nalaman natin yung velocity gamit yung differentiation or derivatives. Ngayon naman yung question is, kung given naman tayo ng velocity this time, paano naman natin malalaman yung position S at any time t? So, yung gagamitin nga natin dito is the concept of integration naman, which is the process of finding the antiderivatives. Ayan. So, kung sa differentiation, yung nakuha natin is from S or from the position to velocity V, then sa integration naman is from velocity V to S. So, basically, it's just the inverse, tinatawag na inverse process ng derivatives. So, for that definition, ito lang siya. So, for example, kunyari given tayo this time ng derivative na f prime of x, then yung antiderivative lang ni f is just defined by this. So si f is an antiderivative of, or the capital F is an antiderivative of the function small f on an interval I if f prime of x is equal to f of x for all x in I. So kung given tayo dito ng derivative, paano naman natin makukuha ngayon yung original function? Ayun. So for example is given tayo ng derivative na 2x. Ayan. So ano yung antiderivative ni 2x? Ano yung original function na ito yung makukuha nating derivative, si 2x? So one answer would be x squared. So si f of x equal siya kay x squared. So bakit? So let's check. Babaliktad naman yung gagawin natin ngayon. So kung meron tayong small f of x equal siya kay x squared, then kapag kinuha kasi natin yung derivative nito, ano lang yung makukuha natin. So kaninang umaga na-discuss na natin yung mga basic integration or basic differentiation techniques, and pag gagamit lang tayo ng power rule dito, makakakuha tayo dito ng f prime of x equals 2x, and denote natin siya as capital F. Ayan. So isang antiderivative ito ni 2x. So paano naman kung, and actually meron kasi tayong tinatawag na representation ng antiderivatives. So aside from f of x or small f of x equal kay x squared, meron din or pwede rin tayo, dapat ito is, no, okay lang to, since notation lang naman. So pwedeng ito is capital F, itong si x or small f. Ayan, so dito sa example, yes. Ayan, so nakita ko yung nag-chat, thank you sa pag-correct. So dito is, para consistent na lang tayo dito sa, ayan, sulat ko na lang siya as f of x, ayan, equal lang siya sa capital F of x, which is equal to x squared. And isa pang antiderivative nito is si x squared plus 1. Bakit? Since kung kukunin natin, so small f na lang din yung gagamitin ko dito. Kasi kung kukunin din ulit natin yung derivative nitong si x squared plus 1, ganun ulit yung makuha natin. Si 2x plus yung derivative lang kasi ng constant function is just 1. And in general, yung antiderivative nitong si 2x is just f of x is just equal to x squared plus c. Ayan. Kasi kahit na kahit na i-derivative natin ito, 2x plus the derivative of a constant is just equal to 0. So 2x and 2x lang yung matitira dito. And we have this theorem or yung sinatawag nating representation of antiderivative. So if f is an antiderivative of f on an interval I, then every antiderivative of f on the interval is of the form f of x, capital F of x, plus c, where c is an arbitrary constant. So kung may makukuha tayong antiderivative, so hindi siya unique, no? Since ganito parati yung magiging form niya. Si f of x plus c, where c is any constant. Ayan. So, take ulit natin yung example na si 2x. Ayan. So, since ito nga napakita natin na yung derivative ni x squared just equal to 2x, then the family, natawag nating family of all antiderivatives of small f of x can be represented by, so denote natin siya as capital G of x, equal lang siya kay x squared plus c. So ito yung capital F of x natin mula doon sa notation kanina, where c is an arbitrary constant. And kapag i-graph kasi natin to is nag-shift lang pataas yung graph niya. So for example, ito or nag-shift siya pataas or pababa from the y-axis. Ayan. So, for example, dito si x squared, itong part na to, no? So, kung nag-add tayo ng 1 kay x squared, then makukuha natin itong graph sa taas. And kapag minus naman or nag-subtract tayo ng 1/2, then itong graph sa baba naman yung makukuha natin. So, ganito yung itsura nung mga antiderivatives natin. So, tulad ng sinabi ko kanina, hindi siya unique since marami yung representation ni antiderivative. Ayan. So, some terms lang. So, again, the process of finding the antiderivative is called the antidifferentiation or indefinite integration. Ayan. And is denoted by an integral sign. So, ganito yung itsura niya parate. So, kung si y equal siya sa integral, so ito is tinatawag natin integral sign of f of x dx. Yung f of natin dito is the integrand and si dx natin dito is yung variable of integration. And equal lang siya parate sa antiderivative of small f plus some constant, which is yung tinatawag naman nating constant of integration. And yung expression na nakuha natin kanina si f of x plus c, yun yung tinatawag nating general antiderivative of f. And each antiderivative of f is called a particular antiderivative of of f. Ayan, tama. So, kung kunyari si c natin dito is specific constant, then yun yung tinatawag nating particular antiderivative. So, ayan. So, tulad nga nung sinabi ko kanina, integration lang is the inverse of differentiation and si differentiation is inverse lang din integration. So, they are inverses of each other. So, if f of x, for example, is equal siya doon sa derivative na capital F prime of x, then pag kukunin natin yung integral or yung antiderivative nitong si f prime of x with respect to x or with respect to dx, then this is just equal to the antiderivative plus c or si f of x plus c. So, ganun din dito sa inverse naman ni differentiation si integration. So, kung given naman tayo ng antiderivative or integral ni f of x dx, small f of x dx, which is equal kay capital F of x plus c, then pag kukunin natin yung derivative nitong integral na to, equal lang siya doon sa original function or doon sa sarili niya. Ayan. So, some basic integration rules. So, kung kanina meron tayong mga differentiation rules, meron naman tayo ngayong integration rules. And since inverse lang ng isa't isa si differentiation and integration, pwede nating makuha yung ibang integration rules or most of the integration rules from the known differentiation formulas. So, yan. So, dito sa first na formula, it's just the, wait. So, clear ba pala itong ano? Medyo blurred siya, no? Ayan. So, the first formula is itong kapag kinuha natin yung integral ni 0 dx equal lang siya to some constant. Since kung kukunin natin yung derivative ng some constant, equal lang siya to 0. Ayun. And ito rin, second is yung sa constant multiple kanina of differentiation. Ganon din yung magiging itsura dito sa integration. So, kabaliktaran lang yung mangyayari. So, pag tinake naman natin yung integral or yung antiderivative ng constant, equal lang siya to the constant times x plus c. So, yan. So, dito is palaging merong c dapat. Ayan. Kung indefinite integration or anti-differentiation yung kino-consider natin. Ayun. And so on. Ayan. So, ito yung ibang formula. So, yung note ko lang dito is yung kay our rule. Ayan. Since dito is kapag kinuha naman natin yung integral o yung antiderivative ni x to the n dx, ayan. So, mag-equal lang siya kay kung kanina sa our rule for differentiation is nag-subtract tayo ng 1 sa original or sa exponent nung function natin, then multiply natin sa sarili niya or multiply natin yung original na exponent. Dito kasi sa integration formula is mag-a-add naman tayo ng isa, then divide. Ayan. So, kung kanina multiply, then subtract, ito is add, then divide. Ayan. So, we'll have x to the n plus 1 over n plus 1 plus c. Where si n dito, hindi dapat siya equal kay negative 1. Since itong makuha natin dito is hindi siya magiging defined, and kasi is ito when n is equal to -1 meron din siyang ibang form. Kunyari when n is equal -1 dito magkakaroon tayo dito ng antiderivative ng x raised to -1 dx or 1/x dx, and yung antiderivative or integral ni 1/x dx is just ln x plus t. Ayan. So dito sa part na 'to. And again, si x dapat dito is greater than 0. So yung isa pang ino-note dito sa antiderivative ng mga trigonometric na function is, again, kung kanina yung mga derivative ng mga nag-start sa letter C na trigo function merong negative, ganun din dito sa antiderivative or integration formula. So yung mga may integral or baliktad na, yung mga merong antiderivative na negative, ayan, letter C pa rin yung start niya. Si cosine, negative cosine x, negative cotangent, and negative cosecant x. Ayan, so dito lang siya yung sa inverse nitong part na to. Ayan, and si e to the x, yung integral niya is just e to the x ulit plus t. Ayan, so baliktad lang yung mga, or inverses lang yung nangyari. And for example, so consider ulit natin yung maglev na example natin kanina. And again, yung position, yung nakuha nating velocity function naman niya is v of t equals 8t, where yung yun naman is paano naman natin hahanapin yung position function ni maglev. So kunyari hindi pa natin alam yung nag-i-internet connection unstable. So naputol ba ako kanina?
Okay lang, ma'am. Okay lang po.
Ayan, thank you po. Ayan, so kunyari hindi pa natin alam yung position function ni maglev. And meron tayong condition dito na si maglev initially nasa origin siya. Ayan. So paano naman natin makukuha ngayon yung position function na s or si f of t? So antiderivative or hindi, antiderivative lang yung gagamitin natin dito. So take natin yung integral ni v of t with respect to t. So ganito yung magiging itsura niya, no? Or note muna natin kasi na si v of t, alam natin na equal siya sa derivative lang ni position function or si s prime of t. So note that si s prime of t kasi equal lang siya kay v of t. And equal ito kay 8t. Ayan. So, para makuha natin si s of t or yung position function natin, then take lang natin yung integral niya or yung antiderivative niya with respect to t. That is, we'll have integral of s prime of t. So, integral yun, hindi siya s, no? So, ayan, sorry po sa handwriting ko pala. So, ayan, so s prime of t dt. So, take lang natin yung integral niya both sides or integral ni v of t dt, or dito kasi is equal lang siya sa integral ni 8t dt. So, paano natin to masosolve? Pwede natin gamitin yung rule natin kanina na itong part na to. The constant multiple of a integration. Constant multiple rule for integration. So, labas natin si 8, then we take integral t dt. Pero since yung antiderivative lang ni t is just, so pwede tayo gumamit dito nung power rule. So, yung gagawin is mag-add lang tayo ng isang exponent. So, yung exponent nito is 1. So, we'll have 1 plus 1. So, 2 over the n plus 1 or yung exponent natin plus 1. Yung mismo exponent natin which is just 2. So, simplifying, this is just equal to 40 squared. So, nakuha rin lang natin yung, so ito si S pala, hindi ko nasulat. Si S equal siya sa integral ni S prime of t dt. So, si S of t natin dito, equal lang siya kay 40 squared. So, ito rin yung dinefine nating position function kanina. Plus C, of course. Ayan. So, yun pala yung isang nakikita ko parati na problem sa students, no? Pag indefinite integral, lagi nilang or may mga nakakalimot isulat itong C. So, kailangan kasi itong C since indefinite integral yung kino-consider natin. Ayan. So, meron tayo ditong assumption pa na si S of 0 or yung initial location nung position is at the origin. Ayan. So, si S of 0, gusto natin siya mathematically, ibig sabihin lang is yung position at 0 is just, at time 0 is just equal to 0. Ayan. So, pwede natin itong gamitin para ma-solve si C. So, substituting, we'll have S of 0 equal siya kay 0 na or 4 times 0 squared. So, from here, plus C which is equal nga kay 0. So, we'll have C equal lang din siya kay 0. So, si S of t natin dito is just 40 squared. Ayan. So, again, nakuha natin yung original na or yung dinefine nating position function kanina for maglev. So, again, kung given tayo ng velocity, pwede nating makuha yung position gamit itong anti-differentiation or integration. So, meron pa tayong tinatawag na, aside doon sa mga integration formulas kanina, meron tayong tinatawag na integration by substitution. So, ito is parang yung inverse process naman ni chain rule. Ayan. So, recall muna natin dito si chain rule. So, kanina nakuha na natin to. Kapag kinuha kasi natin yung derivative or yung itsura kasi kung itsura ng function natin is composite function, then pag tinake natin yung derivative, then meron tayong makukuhang inside or outside derivative times yung inside derivative or derivative of the inner function. So, yun yung define natin kanina. So, dito i-suppose mo natin na si f of x is an antiderivative of f or ni small f. Then, pag i-recall natin itong chain rule kanina, then the derivative of capital F of g of x equal lang siya sa f prime of gx or in the derivative ng outside function at g of x or at u. So, ito yung nilat nating u kanina times yung inner or derivative ng inner function which is g prime of x. Pero alam natin na si f or capital F is an antiderivative of small f. So, by definition, si f prime of x equal siya kay f of x. So, ibig sabihin, si f prime of g of x dito, equal lang siya sa small f of g of x times yung g prime of x na ito. Ayan. Or equivalently, pag tinake natin yung integral or yung antiderivative, both sides, ayan, yung makukuha natin dito is just f prime of g of x times g prime of x dx equal lang siya sa f of g of x plus c. Ayan. So, nabaliktad na siya, no? Ito is yung kapag tinake natin yung integral. Ito yung makuha natin. Si f of g of x plus some constant c. Then, let nga natin dito si u or si g of x as u. Then, si du natin dito is just g prime of x dx. Then, substitute natin to dito sa nakuha nating integral. Then, we'll have si g of x ay si u. Si f of g si small f of g of x ay si capital F of x. So ito is pwede natin kasi itong isulat as f of g of x. Ayan. So para mas madaling makita. Then, kapag substitute natin dito si u equals g of x, then makakuha tayo dito ng f of u. Ito siya. Times cg prime of x, which is just du. So, yung problem natin or itong integral na to is nare-write natin siya in terms of u, which is the integral of f of u du equal lang siya sa capital f of u plus c. So ito yung gagamitin natin o yung tinatawag nating integration by substitution. So paano to mag-work? Ayan. So again, kanina sa chain rule, meron tayong tinawag na outside function or outer function and inside function or inner function. So dito naman is halos or parang ganun din yung gagawin natin, no? So first is yung outside function again natin is si f of g of x. Ayan. And yung inside function natin is si g of x. So kung given tayo dito ng composite na f o g. Ayan, si f. So yung capital F kasi natin dito is the antiderivative of the small f. And kung meron tayong composite function na f o g, tas naka-multiply siya to some derivative nung nasa inside na function, then equal lang siya sa capital F of g of x plus c. Ayan. And ganito yung steps para magamit natin itong integration by substitution or tinatawag din kung minsan na change of variable. So, choose natin si u as si g of x or si u equal siya kay g of x. Yung inside function natin equal siya kay g of x. And usually, it is best to choose the inner part of a composite function such as a quantity raised to a power. So usually, yung mga nilelet nating u dito is yung mga naka-raised to power, no? Pwedeng raised to 2 or kung minsan yung mga naka-square root din na quantities. Ayan. Then, pag nakuha na or pag gumamit na tayo ng substitution na u equals g of x, take natin yung derivative niya, both sides or ayan. So we have du equal lang siya kay g prime of x dx. Then, rewrite natin yung integral in terms of the variable u. So, pag sinubstitute na nga natin itong si u and si du dito sa integral natin, makakuha dapat tayo dito ng integral na in terms lang of u, which is the integral of f of u du. Then, solve na natin itong resulting or solve na natin itong integral na to. Then, meron tayong mahanap na antiderivative na in terms of u and replace natin. So ito yung isa pang ino-note ko since ito rin yung isang napansin ko sa mga students ko kung minsan nakakalimutan nilang since yung nakuha natin is in terms of u, yung nakuha natin integral in terms of u or antiderivative is in terms of u, nakakalimutan nilang ibalik sa original function na in terms of x yung function. So, dito is dapat i-replace natin si u by g of x. So, kung nag-change of variables tayo, kailangan is ibalik natin si u sa original function na in terms of x. Ayan. Then, pwede nating, itong last step kung minsan is hindi na to ginagawa ng iba, no? Pero yan. So, para ma-check natin yung sagot natin, pwede nating gamitin si derivative. Ayan. So, derive lang natin yung nakuha nating integral. So, for example, so ito, consider this example. So, sa first one, ano yung pwede nating i-let dito na u? So, yung pwede nating i-let dito na u is yung nasa loob ng power. So, yun. So, usually, yung nilelet na u kasi dito is yung nasa loob na ng power. So, kung i-let natin ditong huwag na lang siya isulat. Sige. So, i-let natin dito si u equal siya kay x minus 8. Then, take natin yung du which is just equal to dx. Ayan. So, kung makita makita natin agad na kapag kukunin natin itong si wait, lagay ko na lang 'to dito sa taas. So, pag gagamitin natin yung substitution na yan, then we'll have si u equal siya kay x minus 8. So, si u lang yan and naka-raise siya sa 5. Then, si du equal lang siya kay dx. So, we have the integral of u to the 5 du. And ito is, gagamitin lang natin yung power rule for integration. So, mag-a-add lang tayo ng 1 sa exponent over the exponent plus 1. So, we have here u to the 5 plus 1. So, 6 over 6. Then, or 5 plus 1. Plus c. Ayan. So, huwag kakalimutan si c. And si u dito is, huwag din kakalimutang i-transform pabalik kay x. So, we have here x minus 8 raised to 6 over 6 plus c. Ayan. So, dito para sa integration by substitution, so usually is recognize lang talaga natin yung patterns, no? So, kung kunyari dito sa first example, kung makita natin agad na si x minus 8 dito yung pwede nating i-let na u, then good. Pero meron kasing ibang problems na hindi agad makikita kung saan or kung alin dito yung pwede nating i-let na u. So, hindi ako nakapaglagay dito ng ganong problem. So, anyways, ayun. And meron pa pala akong isang ino-note dito kapag yung nasa loob or yung inner function natin is polynomial, then in general, pwede natin ma-solve or polynomial na linear na lang. So, linear kunyari yung nasa loob na inner function, then madali lang siyang ma-solve and yung ite-take lang nga na u parati is yung nasa loob. So, kung kunyari yung form ng function natin dito ay dito na lang sa ibaba, f of ax plus b. Ayan, so linear yung nasa loob. Then, yung ilalat natin parati dito is cu, which is just ax plus b. And yung du parati dito is just a dx. Kung para makuha natin si dx, a dx yan. May nag-annotate po ba? Anyways, so para makuha natin dito si dx, divide lang natin both sides by u or by a. So we have du over a. Ayan. So ganito parati yung itsura kapag linear function yung inner na function natin. Ayun. And dito naman sa second na example, so since yung square root natin dito is, pwede kasi natin itong may rewrite again in terms of power. So pwede nating i-let na yung u natin dito is yung nasa loob. Pero syempre, kailangan muna din nating i-check kung minsan kung magwo-work ba kung yun yung ile-let natin. So, dito is yung nasa loob actually yung pwede nating i-let na u, which is si 4 minus x squared. So, hindi ko na siya gagawin pero isulat ko na lang. And so, yung let natin dito na u is si 4 minus x squared. And yung magiging du kasi natin dito is just negative 2x. Ayan. So, pag sinubstitute natin siya dito, makakakuha tayo ng si 4 minus x squared is u. So, we have u raised to 1/2. And si negative 2x natin dito or 2x kasi yung nandito. So, pwede tayong mag-multiply ng negative para mag-work siya. So, we have negative 2x dx. Or this is just negative du dx. Ayan. Negative du. So, yan. So, ito lang yung kailangan yung i-solve. Si negative ni u raised to 1/2 or square root of u du. So, dito naman sa next example, ano kaya yung pwede nating i-let dito na u? Itong exponent ulit. itong si 2 over x. Bakit? Kasi kung kukunin natin yung derivative niya, this is just equal to negative 2 over x squared dx. Ayan. So, meron lang naka-multiply doon na negative 2, pero pwede tayong mag-divide doon ng negative 2 para makuha natin si dx over x squared, itong part na to. Ayan. So, yung makuha natin dito is e to the u raised or e to the u du over negative 2. Ayun. So, sa next example naman, ganun ulit. So, pwede nating i-let na u dito yung nasa loob. So, we have square root of, yung u is 2x minus 1. So, si du natin dito is just 2 dx. And kung makita nyo, wala tayong, or kailangan nating palitan dito si x. Since yung mangyayari kasi dito is, sulat ko lang. Kung ililet na natin si u and du dito, yung mangyayari is, ito kasi is magiging du over 2 equal siya kay dx. Sorry, medyo makalat na po yung solutions basta dito sa part na to. Then, si x dito is, parang yung mangyayari kasi meron pa rin tayong x na maiwan dito. Then, we'll have u raised to 1/2 du over 2. Ayan, parang meron tayong ganitong itsura dito. So, para makuha natin si x, pwede nating siyang i-derive dito sa substitution natin. So, kapag ginawa natin yun, we'll have 2x equal lang siya kay u plus 1 or si x equal lang siya kay u plus 1 over 2. So, dito is pwede nating palitan ulit si x dito ng u plus 1 over 2 times u raised to 1/2 times du over 2. Ayan. So, paki-simplify na lang din. Ito na yung problem or yung iso-solve ninyo, kukuhanan nyo ng integral. So, dito sa last part, actually ito is hindi rin siya madaling makita kung paano. Kung gagamitin natin yung substitution rule is gamitin lang natin or isulat lang natin siya in terms of sine and cosine. So, I think na-derive naman na 'to nung iba pero yung itsura kasi is sin x over cosine x. Ayan. And gagamitin lang ulit natin yung substitution rule dito. Pwede nating i-let dito si u na si kahit sino sa kanila actually. Pero yung mas madali yatang i-let na u is si sino? Sino dito yung pwede nating i-let na u? Yan. Cosine x, yes. So, pag i-let kasi nating u si cosine x dito, we have du equal siya kay negative sine x dx. Ayan. So, ito is magiging integral lang ng negative du over u. And this is just equal to ln. ln of u. Ayun. So, yun. So, hindi ko na siya tinapos na i-solve. So, ganun lang parate, no, yung gagawin natin kung substitution rule. So, later kasi mas marami pang integration techniques. Pero I think wala, beyond na siya sa senior high topics. Ayun. So, dito sa part na 'to is kailangan lang nating ma-recognize agad kung sino yung pwede nating i-let na u dito or yung gagamitin nating substitution. So, ayun po. So, ito yung other integration formulas. Ito nga siya, si integral ni tan x dx. So, itong ibang trigo, itong part na 'to, itong 4 na trigo yung integral ng trigonometric functions na 'to is pwede nga siyang ma-derive gamit yung substitution rule. So, si integration by substitution, tinatawag din siya minsan na u substitution or u sub, ayun. And ito rin, pwede rin siyang ma-derive gamit yung u sub natin. So, the definite integral naman. Yung kanina indefinite integral yung mga or yung na-discuss natin. So, ngayon naman is si definite integral. And dito yung ginagamit kasi is yung tinatawag na area problem or yung finding the area under the curve. So, hindi ko na po nilagay dito yung derivation, pero yung idea lang is kung kunyari meron tayong curve, so kunyari itong color blue dito, yung gagawin lang is gumamit tayo ng mga rectangles. Ayan, so pwede tayong mag-drawing ng mga rectangles under nung curve. And partition lang natin itong curve natin, no? Then pwede tayong mag-drawing ng mga rectangles. Then kapag pinarami natin 'tong mga rectangles na 'to or kunin natin yung sum ng mga rectangles na 'to. So meron yung tinatawag nating left Riemann sum and right sums, ayan, right Riemann sums. Then kung minsan is midpoint rule din yung ginagamit, which is yung gitna lang nung rectangles yung kino-consider na approximation, ayun. So dito is I think wala siyang dito sa particular example na 'to is hindi siya or yes, wala siyang specific na endpoints or yung approximation. So kahit na ano yung kinuha dito and gano'n lang yung idea. Kunin mo lang yung mga sum nung lahat ng rectangles na 'to, then kunin natin yung limit or paramihin lang natin ng paramihin 'tong partitions, then dumadami din yung rectangles, then take yung limit as n approaches infinity or pag pinaparami kasi natin yung mga rectangles dito, mas na-approximate niya yung area under nung curve, ayun. And ito yung theorem about the definite integral as the area of a region. So si f natin dito is continuous and non-negative doon sa closed interval na AB. Then yung area, the region, bounded by the graph of f, the x-axis, so bounded by f, the x-axis, and the vertical lines x equals a and x equals b is just the integral from a to b ng f of x dx. So ito yung tinatawag nating definite integral ngayon, and yung a and b natin dito yung tinatawag nating limits of integration. So basically, ito is kinukuha lang natin yung integral evaluated from A to B na ngayon. Ayun. And so paano naman kung si F natin is hindi positive? So gano'n din lang yung mangyayari, no? So kung si F kasi hindi positive, then yung graph niya is below the x-axis. Ayan. Then each value ng F negative siya. So si f of x delta x natin dito magiging negative din. Then yung area natin dito is maka-count natin as negatively. Then yung definite integral natin is just the negative of the area. Ayun. So magwo-work pa rin siya pero magiging negative lang yung value. And some properties of the definite integral, so hindi ko nasuot dito, pero si f is integrable dapat siya doon sa interval na AB. Ayan. So yung first na properties is meron tayong definite integral from A to A ng f, equal lang siya parati kay 0. Ayun. And kapag meron naman tayong integral from A to B ng f of x dx, equal lang siya sa negative naman ng integral from B to A ni f of x dx. So nag-switch lang yung limits of integration natin dito. And ito is yung kamukha rin lang nung properties kanina sa indefinite integral, which is the integral from A to B ni k times f of x dx equal naman siya sa constant times nung indefinite integral natin from A to B. So dito is yung sum nung definite or yung definite integral ng sum ng two functions, equal lang siya sa sum or sum ng definite integrals. Ayan. And lastly, kung meron tayong C, kunyari, any number C doon sa interval na AB, then pwede natin i-partition yung definite integral natin from a to b, mag-equal lang siya sa definite integral from a to c plus the definite integral from c to b. Ayun. So, excuse lang po ulit saglit. Ayun. So, meron din tayong tinatawag na fundamental theorems of calculus. So, yung idea dito is kung kunyari meron tayong limit of o yung change in position kasi equal lang siya dun sa limit of Riemann sums nung velocity v natin or yung definite integral from a to b f of t dt. So, in terms of t, yung function natin dito since time yung kino-consider natin. So, kung i-denote natin yung position function natin as f of t, so yung change in position natin is pwede natin siyang maisulat as yung capital F of b minus f of a. Then yung definite integral lang from a to b f of t, equal lang siya sa change in position from t equals a to t equals b. And this is just equal to f of b minus f of a. So, dito is yung definite integral ni f of t dt is the integral lang ni v, which is yung position natin. So, kaya natin nakuha tong part na ito. Ayun. And ito yung connection between the integral and the derivative. So, yung position f natin, so kanina is so medyo confusing yung mga notations. So, ito is kanina s tapos is small f, tapos naging velocity. So, this time is ilet na lang natin na yung position natin is capital F and yung velocity natin si small f. Then, related siya using derivative. So, napakita na natin to kanina. Parang yung s prime of t natin equal siya kay v of t. Ayun. So, ito ngayon yung tatawagin nating fundamental theorem of calculus. And pwede natin itong i-apply to any function f with continuous derivative. So, si capital F natin dito is yung antiderivative natin or yung position natin. Ayan. And ito yung dalawang theorems or yung tinatawag nating fundamental theorems of calculus 1 tapos si 2. So, suppose muna natin na si F is continuous siya dun sa closed interval AB. Then, yung FTC or yung fundamental theorem of calculus or the first fundamental theorem of calculus, it's just given by this. So, kung si G natin dito is, equal siya sa integral from a to x ni f of t dt. Then, pag-take natin yung derivative nitong function na to, so we have d over dx a to the x f of t dt, then equal lang siya kay f of x. Ayan. And dito is, pinalitan lang natin yung variable, no, since yung limits of integration natin dito is from a to x. Si x dito is variable siya, so nagbabago siya depende doon sa specific or doon sa value na i-consider natin. So, dito is, kung i-graph kasi yung ganito yung itsura niya. Ayan. So, meron tayong area under the curve since nakuha natin na si f of t or yung area under the curve is just the definite integral. So, we have here the area. Ayan. And kung si x is any number siya between doon sa interval na a to b, so yung area lang natin is itong shaded na region. And pwede nating palapitin or paguhin yung value dito ni x. Ayun. So, for the second fundamental theorem of calculus, ganito naman yung sinasabi. So, kung si f natin dito is capital F is any antiderivative of the small f, that is si f prime, capital F prime equal lang siya sa small f, then integral from a to b, f of x dx is just equal to the antiderivative at the function at the value b minus it's the capital F at a or yung antiderivative evaluated at a. Ayun. And itong dalawang theorems na to is parang sinasabi lang nito nga na inverse processes lang si derivative and si integration. So yung connection nilang dalawa is pwedeng ma-verify gamit itong fundamental theorem of calculus. So dito sa second na graph is ayun lang. So sa differentiation kasi is yung ginawa nga natin is ginawa natin yung slope ng tangent line. So sa integration naman is yung area of the or area under the curve. Wait lang po. Ayan. And pati yung sa process is ito is magkakaroon kayo dito ng delta y over dx. Itong isa is magmumultiply kayo delta y times dx. Ayun. So parang inverse din yung processes niya. So lastly, we have the areas of a region between two curves. So ito is yung application naman ng definite integral natin. Ayun. So given tayo dito ng two curves, so hindi na lang si x-axis yung bound or yung isang bound natin, no? So dalawang curves na yung i-consider natin. So paano naman natin kukunin yung region between these two curves? Ayan. So yung gagawin natin is ganito. So kung kunyari pinapaano sa atin is yung region between kunyari si f, yung isang curve natin is defined by this function f, yung isang curve naman natin is defined by this function g. And yung yung area lang between f and g is just equal to the area ni f. Ayan, so yung area kasi ni f dito is itong buong to. Yung function or yung graph natin is CF, itong nasa taas na function. So yung area niya is yang buong yan mula dun sa interval na AB. Minus yung area naman under G. Yung si G is itong function natin na nasa baba. So yung area niya lang is itong shaded region sa baba. So pag i-subtract natin itong buong area ni F sa area ni G, then makukuha natin itong area between F and G. Ayan. So state lang natin, ganito yung mangyayari. So kung meron tayong continuous function na F and G, doon sa closed interval na AB and si f of x natin dito is greater than or equal to g of x. So si f natin dito is mas malaki compared sa g. For all x in AB, then the area of the region bounded by the graphs of f and g and the vertical lines x equals a and x equals b is just given by this equation. So si a equal siya sa definite integral from a to b ni f of x minus g of x dx. Ayun. So, ganun yung magiging itsura niya. So, kung kunyari si g of x natin dito ay yung, so balikan natin yung graph. If yung g of x natin dito is itong x-axis, then magpa-follow pa rin yung definition natin ng definite integral as an area kanina. So, since ito is magiging 0 lang si g of x. So, si integral or yung area natin is just the integral from a to b ni f of x dx lang kung x-axis si g natin dito. Ayun. So let's consider some examples. So first, find the area of the region between the graphs of y equals e to the x and y equals x and the vertical lines x equals 0 and x equals 1. So ganito yung itsura nung graph. So meron tayong y equals e to the x. So ito yung graph niya. And meron din tayong graph or curve na y equals x. So itong red line. And bounded siya sa left by x equals 0 and bounded siya sa right by x equals 1. So pinapahanap sa atin is itong area nung shaded na region. Ayan. So gagamitin lang natin yung formula natin, which is just si f minus g or yung definite integral ni f minus g. So, dito kunyari kung hindi given sa atin, kunyari wala itong wala itong graph na 'to. Then yung first na gagawin is siyempre i-try muna nating i-plot yung mga given na functions, ayun. And then, tignan natin kung sino yung nasa taas na function and sino yung nasa baba na function. Then, yung nasa taas yung ile-let natin na si f and yung nasa baba yung ile-let natin na si g. Ayun. So, dito sa graph na 'to yung ile-let nating f is si so, si f of x equal siya kay y which is equal kay e to the x. And yung ile-let naman nating g is si y equals x. Ayan, or si g of x equal lang siya kay x. Ayun. Shorthan ko na lang yung f of x equal siya kay e to the x and si g of x equal siya kay x. And yung bounds na binigay sa atin dito, yung magiging limits of integration natin is si x equal siya kay 0. So, ito yung magiging a natin. And si x equal siya kay 1. So, si 1 yung magiging b natin dito, yung limits of integration natin. And gamitin natin yung formula for the area under the curve. So, we have a equal lang siya sa integral from a to b ni f of x minus g of x dx. Ayan. And substitute lang natin yung mga values. Then, we have 0 to 1 dapat yun. We have 0 to 1 ni f of x which is e to the x minus x dx. Ayan. And so, pwede natin gamitin yung mga property kanina. So, we have 0 to 1 ni e to the x minus dx. Dapat to. dx minus 0 to 1 ni x dx. And alam natin na yung integral ni e to the x is just e to the x. So, evaluated na siya from 0 to 1. And sige, pagsamahin ko na lang po. So, ito is minus integral naman ni x is just x squared over 2. So, we have minus x squared over 2. Evaluated tong dalawang to from 0 to 1. Ayan. So, evaluate lang natin. We have e raised to 1 minus 1 squared over 2 minus e raised to 0 minus 0 squared over 2. So, itong first is magiging e minus 1 half. Yung second is magiging, this is 1 and this is 0. So, we have minus 1 lang yung matitira dito. So, e minus 1 half minus 1. So, we have here e minus 3 halves. So, si 3 halves ay negative or 1.5, no? So, si e is around 2.78. So, 2.78 minus 1.5. So, this is greater than 0. So, ito ngayon yung area between these two curves na. So, yan. So, ginamit lang natin yung formula natin. So, paano naman kung meron tayong area or meron tayong two intersecting graphs? Paano naman natin makukuha yung area ng region na yun? So, ayan. So, possible kasi na makuha tayo ng kung kanina given na sa atin yung upper and lower boundaries or given na sa atin yung endpoints or si A and B, possible kasi na hindi given, hindi ibibigay sa atin si A and B or yung bound niya sa left and right side. So, possible din na yung graph natin, ayan, mag-intersect siya doon sa endpoint or kay A and B. So, paano naman yung gagawin natin dito? So, for example, dito sa figure na to is nag-intersect yung F and G natin sa A, dito sa part na 'to, and dito sa kabila is both naman. Both sides yung nag-intersect. So, 'pag gano'n yung nangyari then, compute natin yung kailangan nating i-compute yung limits of integration natin, and para magawa yun is kunin lang natin yung point of intersection nung dalawang graph. Ayun, so 'pag nakuha natin yung point of intersection nung dalawang graph, then yun na yung magiging limits of integration natin. So, paano ba makukuha yung, point of intersection nung dalawang graph? So, i-let lang natin or i-equate lang natin silang dalawa, then solve for x. Ayun po. So, for example, so given tayo ng sine and cosine curves. So, si sine dito is itong upper function, and itong upper siya dito sa part na 'to hanggang sa this is pi over 40 or 5 pi over 4 pala, sorry. Ayan. Then ito naman si cosine of x is itong nasa lower, hanggang kay 5 pi over 4. So, paano naman natin ito iso-solve? So, hindi given dito yung kailangan lang nating solve dito is yung shaded na region. So, itong region na lang na 'to kunyari, and hindi given sa atin yung bounds sa left and sa right side. So, i-solve muna natin yung kung saan mag-i-intersect yung dalawang function natin or yung point of intersection natin. So, equate natin dito si sin x and si cosine x. So, sin x equal siya kay cosine x. So, paano natin makukuha si x dito? So, pwede nating i-divide both sides by cosine x. So, diretso ko na lang po. Ito is over cosine x. So, we'll have here tangent x equal lang siya kay 1. Then, saan ba magwa-1 si tangent x? So, kunin lang natin yung inverse niya. Tangent inverse ng 1. And yung interval na i-consider na lang natin dito is 0 to hanggang sa 5 pi over 4. Ayan. So, yung x natin dito is magiging pi over 4 and 5 pi over 4. Ayan. So, ito na yung magiging or ito yung points of intersection ni sine and cosine. Then, ito na yung magiging limits of integration natin. So, si a natin dito is magiging si pi over 4. So, based din kasi dito sa graph, ito actually si pi over 4. Ayan. And ito is na kanina si 5 pi over 4. So, bago natin kunin yung area, let lang muna natin si f dito na si sin x. So, nasulat naman na si f natin dito si sin x and yung g natin dito is si cosine x. Again, kung hindi nabigay itong graph, then kailangan natin itong i-graph manually or pwede rin po nating i-check yung graph sa any graphing tool. So, marami naman pong available na graphing tool online, just like yung GeoGebra or Desmos. Ayan. So, pwede rin si WinPlot. Ayun. So, free naman po siya. And dito is, nabigay na kasi yung graph, no? So, for illustration lang po. So, si f natin dito is si sin x and si g natin dito si cosine x. And yung magiging limits of integration natin dito is from pi over 4 to 5 pi over 4. So, si a natin dito si pi over 4 and si b natin dito si 5 pi over 4. Ayan po. So, bounded yung graph natin from the left ni pi over 4 and bounded siya sa right ni 5 pi over 4. Tapos bounded above siya ni f and bounded below ni g, which is si cosine x. So, gamitin lang ho ulit natin yung formula natin, which is integral from a to b ni f of x minus g of x dx. So, si a and b natin dito is pi over 4 to 5 pi over 4. Si f of x natin dito is si sine x minus cosine x, si g dx. Yung integral lang ni sine x is just negative cosine x. Si cosine x naman is sine x, pero may minus doon. So, we have minus sine x. Ayan. So, evaluated siya from pi over 4 to 5 pi over 4. Ayan. Si negative cosine ni 5 pi over 4 ay or i-rewrite ko na lang ho. Ayan. So, hindi ko na po ito tatapusin since wala na naman pong time, no? Basta ganito po yung mangyayari doon sa problem. Ayan. So, kung given tayo nung two intersecting or region between two intersecting graphs, then pinapahanap yung area and hindi given yung mga bounds sa left and right, then check lang natin itong point of intersection niya. So, ito lang yung gagawin. Equate lang natin yung dalawang equations, then solve for x. Ayun po. Then, yun na po yung magiging limits of integration natin. So, for the next case, ganito naman. So, how do we find the area of a region between two curves that intersect at more than 2 points? Ayan. So, ganito yung magiging itsura ng problem natin. So, kung kanina is nag-intersect lang siya sa 2 points, ngayon naman is more than 2 points na yung intersection niya. So, ito yung gagawin. So, first, determine muna natin lahat ng points of intersection. Then, check natin kung ano yung curve above or yung curve below. Ayun. Between doon on each interval determined by this point. Then, subdivide natin yung given region into several regions. Ayun. So, kunyari dito po sa example is na-divide siya into 3 regions. Meron tayong S1, S2, and S3. That's kunyari si Y natin dito or si F natin dito is itong pink na curve. And itong si G natin is si blue curve. So, dito sa part ni S1 ay yung pink na curve or si F yung nasa taas na curve. Ito namang nasa baba is si G. Dito naman kay region S2, si G yung nasa taas, then si F yung nasa baba. Ito namang si S3, si G, si F yung nasa taas, then si G ulit yung nasa baba. So, kunin lang natin yung sum nung lahat nung na-subdivide na region, then yun na yung magiging area nung total na region natin. And kung merong case na si G yung mas mataas, kasi yung sa definition or doon sa dinefine natin kanina is si F dapat is greater than or equal to G. So, mag-work pa rin naman yung definition natin, no? Kahit na si G yung nasa baba. So, kasi yung mangyayari lang is kung yung area natin magiging equal lang siya sa A to B ni f of x minus gx. So, ganito na lang po. Kung si f of x natin is greater than or equal to g of x, ayan. So, si f of x minus g of x natin dito is positive. Kung si g of x naman natin is Kung si g of x naman yung nasa taas, then si g of x minus f of x naman yung magiging positive. So, pwede lang po nating i-take dito yung absolute value ni f of x minus g of x. Then, meron kasi tayo nung remark natin kanina na paano kung yung graph yung nasa ibang case po pala yun, no? Ibang case po pala yun, sorry. So, itong part na 'to is same lang naman yung makuha nating area kung si G natin dito yung nasa taas. Ayun. So, ganito yung mangyayari, no? So, yung area between the curves y equals f of x and y equals g of x, and between x to a to x equal to b is just the integral from a to b ni absolute value ni f of x minus g of x dx. So, ito is yung sa isang part lang po ito, hindi siya yung buo. So, kunyari dito sa part na 'to. Ayan. So, para magamit or para makita natin, so paano naman kung given tayo nitong example na ito? So, find the area of the region between the graphs of f of x equals 3x cubed minus x squared minus 10x. And g of x equals siya kay negative x squared plus 2x. Ayan. So, ganito po yung itsura nung graph natin. And, ayan. So, excuse lang po saglit, no? So, ano po kaya yung magiging intersection points or points of intersection natin dito? So, yun po. Kung isa-solve po natin yung point of intersection, so equate lang ulit natin dito si f and g para mas kita natin kung saang point sila mag-i-equal. So, si 3, so f of x equals g of x, magiging 3x cubed minus x squared minus 10x siya. Equal lang siya sa negative x squared plus 2x. Then, ilipat or combine natin lahat nung may same na variable. So, we have here 3x cubed minus x squared. Ito is magiging plus x squared. So, magzi-zero siya. Si minus 10x, magma-minus itong isa. So, magkakaroon tayo dito ng 2x or minus 2x. So, we'll have minus 12x dito sa kabila. Equal siya kay 0. Then, pwede nating i-factor out dito si 3x. So, magkakaroon tayo ng 3x times x squared minus 4 equal siya kay 0. So, si x dito is, yung isa is x equals 0 or si x squared minus 4 natin is equal to 0. And computing for x here, we'll have x squared equals 4 or x equal lang siya sa square root ni 4 which is positive or negative 2. So, meron tayong dalawang values, negative 2 or 2. So, yung point of intersection nila is, makita naman dito sa graph, si x equals negative 2, x equals 0, and si x equals 2. So, tulad nung mga steps doon, steps na nasabi na kanina, then, yung gagawin natin is, subdivide natin itong region natin depending dito sa point of intersection na nahanap natin. So, pwede nating i-divide yung region natin to 0 or negative 2 to 0 and 0 to 2. Ayan. And dito sa negative 2 to 0 na region, si G natin dito, or si F kasi natin is itong graph na ito, si dark or yung black. Then, yung G natin dito is itong lighter color which is gray. So, dito sa region na negative 2 to 0. Si F natin dito yung nasa taas and si G yung nasa ibaba. Ayun po. And dito naman sa region na 0 to 2, yung nasa taas natin is si G and yung nasa baba is si F. So, ganito po yung mangyayari dun sa problem. So, we have here A equals, diretsyon ko na po, from negative 2 to 0. So, hindi ko na po sinulat pero si F natin dito ay si 3x cubed minus x squared minus 10x and si g of x equals siya kay negative x squared plus 2x. So, integral from negative 2 to 0 ni f of x which is f of x yung nasa taas. Sige po, sulat ko na lang po f of x minus g of x dx plus integral ni 0 to 2 si G naman po yung nasa taas dito. So, magiging G of X minus F of X dx. Ayan. And substitute lang natin yung values then or yung mga functions. Magkakaroon tayo dito ng F natin is si 3x cubed minus x squared minus 10x minus si G of X natin dito is si negative x squared plus 2x. I-set up ko na lang po and itong isang integral naman is si G yung nauna or yung nasa taas. So, we have negative x squared plus 2x minus f which is 3x cubed minus x squared minus 10x dx. Ayan po. So, ganito yung magiging itsura ng problem. So, dito is kailangan muna nating i-solve yung point of intersections and hatiin natin yung region natin. Then, kung sino yung nasa taas na curve, so yun yung mauna and yung nasa baba yung parating i-minus doon. Ganun po yung mangyayari. So, for the last example, hindi ko na po ito itutuloy. Ayan. So, paano naman ito? Reverse naman natin yung roles nila x and y. So, kung kanina puro yung kinuha nating region is function of y tapos in terms of x, function of x pala yung mga or in terms of x yung functions natin kanina or equations. Paano naman ngayon kung yung kukunin na natin is si f of y or function of y na? So, ganito naman po yung gagawin natin. So, kung yung region natin is bounded naman siya ni x equals f of y, so ito siya. And si x equals g of y. Ito naman po yung curve na red. And horizontal lines naman yung, horizontal lines naman yung bounds natin dito. So, meron tayong y equals c and y equals d na curve. Where si f natin dito is or are continuous and si f natin dito is greater than or equal to g of y. Ayan, so mas malaki yung f of y natin compared kay g of y. G of y for c greater than or equal to d. So si c is yung nasa babang bound and si d yung nasa taas na bound. Then yung area naman is given by this equation. So si a equal lang siya from integral si a equal siya sa integral from c to d ni f of y minus g of y dy. So, ngayon is in terms of y na yung magiging differentiation or integration natin. So, kanina puro in terms of x, ngayon naman is in terms of y. So, pwede natin tong gawin kung mas madali. Kung yung given na function sa atin is mas madaling i-express in terms of y, no, compared sa kung in terms of x siya. So, for example, ito po. So, find the area of the region enclosed by x equals y squared and y equals x minus 2. Then, integrate natin siya with respect to y. Ayan. So, dito is, ayan. So, in terms of y, na kung yung iti-take natin ditong function is f of y or g of y, so in terms of y na to agad si y squared. dito naman sa kabila pwede nating i-transpose si y para magkaroon tayo dito ng x equals negative y, baliktad, y plus 2 pala. Ayan, so pwedeng in terms of y na yung magiging function natin dito. And kapag i-graph kasi natin ito is si x equals y squared, it's just the parabola opening to the right. Ayan. And yung si y equals x minus 2 naman or si x equals y plus 2 is this line here. So, ganito yung magiging itsura ng region natin and yung bounds dito is hindi binigay. So, kailangan ulit nating i-solve muna yung bounds bago natin makuha yung region. So, paano yung gagawin natin? Equate lang ulit natin itong equations natin, pero this time is in terms of y na. So, we have y squared equal siya kay y plus 2. Ayan. And ito is pwede natin siyang i-transpose. So, we have y squared minus y minus 2 equal lang siya kay 0. So, si y natin dito is magiging equal lang siya sa factorable kasi ito. So, we'll have y 2, 1. Ito is minus plus. So, si y natin dito is equal sa 2. And si y natin is equal kay negative 1. So, si y equal lang siya kay negative 1 and ano po nangyari? Ayan. So, si y natin equal siya kay negative 1 and 2. So, ito na ngayon yung magiging limits of integration natin. And based dito sa graph, yung magiging f of y natin is itong itong nasa taas na graph, which is wait lang. Kung in terms of x, so ganito po pala yung mangyayari, no? Ayan. So, yung magiging y, f of y natin is itong nasa right na function since mas mataas siya compared doon sa g of y na nasa left na function. So, ayan. So, yung magiging f of y natin dito is yung nasa right na function which is itong f of y equals y plus 2. So, si f of y natin dito is y plus 2 and si g of y natin dito is y squared. Ayan. And yung c yung ginamit natin dito constant of integration from c to d na, no? So, si c natin dito is negative 1 and yung magiging d natin dito is 2. So, yung magiging itsura nung area natin is i-set up ko na lang po since wala ng time. We'll have a integral from c to d ni f of y minus g of y dy. Ayan po. And si c is equal lang kay negative 1, then si d is equal kay 2. And si f of y natin is just y plus 2 minus si g of y natin is just y squared. So, dy. Ayan. So, kapag solve po natin itong integral nito, yun po yung magiging area natin between this curve or area under this curve. Ayan po. So, for the last example, so balik lang tayo doon sa problem natin in motion. So, yung real life or one real life na interpretation kasi nung area under the curve is this. So, consider two cars, si car A and si car B that traveling in adjacent lanes along a straight stretch of highway. Ayan po. So, yung velocity function for car A is v equals f of t and yung velocity function naman ni car B is si g of t. Ayan. So, kung i-graph natin siya dito sa xy plane natin or tv plane since time and velocity yung problem natin dito is just si v equals f of t natin dito yung velocity ni car A. Ayan. So, nasa taas siya na curve and yung velocity naman ni car B is itong si v equals g of t. So, yan. So, yung shaded area dito gives the distance that car A is ahead of car B at time T equals B. So, isang application lang po ito nung area under the curve. Ayun po. So, application na po yung area under the curve ni integral pero meron pa po siyang interpretation in real world problem. So, dito ko na po i-end yung talk ko sa yun. So, ayan. So, again, ito po ulit yung reference ko. Same lang po dun sa reference ko kanina. So, thank you po for your attention. Thank you po for listening.
And so thank you, Ma'am April, for that very nice and informative discussion. Okay, so nasa Q&A portion na po tayo ng ating program. So sa mga may katanungan po, please drop your questions in the Zoom chat box or dun sa mga nanonood via YouTube live streaming, put your questions in the YouTube live chat. And so if possible, kindly include your name and affiliation. Okay, so kanina pala, I think may isang po tayong tanong from dito sa ating YouTube live stream from Romeo Madrona. Ang question niya is it acceptable to have a negative value of area using integral, knowing the concept or context of an area?
Okay po. So, yung area kasi is, yun nga po, positive siya parate since area nga po yung pinag-uusapan. Pero yung sinasabi lang kasi nung negative na part is parang nasa baba lang siya, ganun po yung idea. So, yung area is yun lang mismong positive na value, pero yung parang direction or yung ano po ba yung example na yun? Ito po ba yung tanong? Ayan. Ayan. So, parang negative lang siya nung mismong area. So, yung pong area natin is yung positive value lang, pero negative lang to account na nasa baba siya nung x-axis natin or nung curve po natin.
And so I hope, Sir Romeo, nasagot po yung tanong ninyo. And so may further questions po ba tayo from our participants? Okay, so we have here from Joshua Nico Bati. What are other real life applications of integration in other disciplines po?
So, usually po yung real life applications ng integration is sa physics po siya usually po makikita eh. So, for example, ito nga pong distance and velocity. Then, pwede rin po sa work, nakita rin po siya sa work. Tapos, sa mga volumes din po sa paghahanap ng mga volumes. And sa econ naman po is, I think pwede po siyang magamit to solve the cost, total cost and total profit functions, mga ganun po, no? And sa stat naman po pwedeng siyang magamit to compute yung probability density functions. Ayun po. And hindi ko po kasi na-tackle dito yung differential equation. So, parang isang applications po siya nung integration and mas marami na naman pong applications po yung sa differential equation since pwede pong mahanap dun yung or yung mga usual applications po dun is yung population growth nga po, bacterial growth or sa modeling po. Ayun po.
Ayan. So thank you, ma'am. Ayan. So may mga tanong pa po tayo. Okay, so from Geneville Intero, ask ko lang po anong app po ang ginamit para maipakita yung solution?
Solution po nung alin po? Alin pong solution? Or yung graph? Ay, yung graph po ba?
Pag-solve daw po ng mga problems. Ayan.
Paano app po yung okay po. Ito pong app po mismo na ano, yung ginamit ko po dito is PDF exchange po. Ito pong sinulatan ko pong problem, ay ito pong sinulatan kong PDF. Po ba yung tanong? Ayun po. PDF exchange po yung ginamit ko po dito.
Yun daw po ma'am, PDF exchange. Ayan po,
Tapos dun sa isa pong notepad kanina is write. Ayun po.
okay, I think nag-raise po ng hand si Sir Rogelio. Sir Rogelio? Okay. Yes, sir, you have a question for or questions for Ma'am Pajimola? Nawala ata siya. Ayan. Okay, we have here a question from or questions from Anita Parungao. Okay, how do you find po integral ng is this 2x plus 1 dx po ba or the absolute value of 2x plus 1 po? The absolute value, how do you find po integral ng absolute value of 2x plus 1 dx? How does it differ from integral ng 2x plus 1 dx? Ayun po.
So, yung absolute value po ni 2x plus 1 dx, meron po kasi siyang dalawang values. So, dito ko lang po isulat. So, kunyari, meron tayong absolute value ni 2x minus 1 dx or 2x minus 1. Absolute value 2x minus 1. So, meron po kasi siyang dalawang values. So, pwede po ito is maging 2x minus 1 kung si 2x minus 1 natin is greater than 0 or equal to 0. Tapos, magiging negative po yung value niya, 2x minus 1. Kung, wait po. Ano po, saan po galing itong, doon po ba to sa area po kanina? Ayan, so ituloy ko na lang po. Tapos, meron po siyang isang value po na negative 2x minus 1 kung depende po dun sa interval na 2x minus 1 less than 0. Ayan po. So, ito is magiging 2x minus 1 yung value niya if si x natin is saan po? If x is greater than or equal siya kay 1/2 and yung negative 2x minus negative 2x plus 1 naman kung si x natin dito is less than 1/2. So, pag kukunin po natin yung integral nito, pwede po maging dalawa yung value niya, depende po doon sa ito po, either dito sa dalawa yung pwedeng maging value niya, no? So, depende doon sa interval na i-consider po natin. Pero I think doon po, ito po yata yung dito sa merong absolute value ni, ito po ba? F of x minus g of x dx. So, yung sinasabi ko lang po kasi dito is, kung si f of x is mas mataas kay g of x, then mag-work pa rin yung formula natin. And kung si g naman yung mas mataas or yung nasa area na, or yung curve sa taas, then si f yung nasa baba, then same lang din po yung area na makukuha natin. So, ito is yung absolute value lang po talaga na value po yung kinonsider natin dito.
Ayan, thank you ma'am. Ma'am, pwede daw pong pakibalik dun sa solution and then paki-zoom in kasi daw hindi daw makita yung solution. Ayan.
Ito po ba?
I think, opo. Yung sa absolute value of 2x plus 1 po ata.
Okay po.
Ayan. Paki-zoom, ano ba? Na lang daw po. Okay. Ayan. Ayan po, may mga tanong pa po tayo. Okay. And so I think that's it. Before tayo thank you again, Ma'am Aprimel. So before po tayo mag-leave, kindly fill out po yung evaluation form, which is posted na po sa ating Zoom chat box and nasa comment section na rin po ng ating live streaming sa YouTube. Okay, so as part of evaluating the Track A Lecture 7 session of Miss Aprimel Chris J. Pachimola during the 26th summer school in the natural sciences and mathematics kindly accomplished the evaluation form by accessing the provided link. And so the evaluation form will serve as your attendance. Please be reminded that to receive a certificate, you must have at least 75% attendance in the 3-day event. Lastly, please make sure that your full name and email address are correct. Your full name will appear on your certificate. Ayan. So thank you po. And then, okay. Before po tayo mag-leave again, pwede pong pa-request na mag-open tayo ng webcam para po magkaroon tayo ng photo op. Ayan, as requested po ng ating lecturer. Okay, thank you po.
Thank you po ulit sa mga umattend po today. And happy Mother's Day po pala sa mga mothers out there. Ayun po.
Okay po, sige po. Paki-on na lang po para makapag-count na ako. Okay, so at the count of 3, 1, 2, 3. Ayan. Again. 1, 2, 3. Isa pa po. Ayan, 1, 2, 3. And then last na po, 1, 2, 3. Okay. Ayan, so thank you so much po. Hindi pa po tapos yung ating program. Meron po tayong plenary talk this at 2:45 p.m. Okay, so sa plenary talk po, magsasalita po ang ating Department of Mathematics and Computer Science Chair, Professor Rizabel Adawe. So yung link po is send na sa inyong email address, or kapag hindi niyo po mahanap yung link or yung email address nyo, yung in-email sa inyo, sorry, paki-visit na lang po yung page ng SINSM. Andun po yung link ng YouTube live streaming po. Okay? Yun lamang po. Okay, and once again, thank you po. Ayan.
Thank you po ulit. So, meron pa pong isang plenary talk. Thank you po.